This conference will now be recorded.
Okay, so chapter 6, this is what we're going to talk about in chapter 6. And these are the topics that we're going to discuss in this chapter. Okay. All right. Okay, now you guys are familiar with this, right? You know what this is, correct? Everybody knows what the standard networking device, the different layers are. Do you remember them? Do you guys remember these? Okay, don't forget them. You're gonna need to know them in Security Plus. Okay, you're gonna need to know these in Security Plus. Okay, so definitely you guys know physical layer number 1 is the hub, 2 is the switch, 3 is networking, 4 is transport, and 5, and then 6 and 7, and 7 is the application phase. Okay, so again, when you guys took Network Plus, when you guys went over this, did he teach you a certain way to remember this stuff? Y'all remember? Was there any kind of format that he told you how to learn
Yeah,
these different?
please do not throw Stephanie's sausage pizza away.
What's that?
He said, please not throw Stephanie's pizza away.
Okay. Please not
Throw Stephanie's pizza away.
Please.
Steady.
Okay. Okay.
Because I had threw her pizza away and got it wrong because I missed the head.
Okay, so what was it now? Please what?
Do not throw.
Oh, okay, I got it.
Stephanie's pizza away.
Please do not throw Stephanie's pizza away. Okay, that's pretty cool. That's
We've been throwing her pizza away ever since then, you know?
Yeah, I mean, but you know what though? Does it stick with you guys? Does that stick with you guys? Does it stick? Okay, cool. As long as it works for you guys, if that's not something that you wanna memorize it a different way, then just pick out a way to memorize it. When I studied this, I didn't have like I said, I didn't have a saying.
You didn't have a Stephanie.
No, I had to study the different ones and flashcards to figure out what was what. But I think that's a good way. The reason why I brought it up because I wanted to see if there was, because Mark is good at throwing stuff out like that. I just wanted to see if he threw that out to show you guys a way to I'm not gonna say memorize this, but I guess, but to help you fully understand what each level does and why each level is important. Because without these levels, a lot of things wouldn't work. You know, without the physical layer, what you gonna do? You gotta have the physical layer, right? Nothing else is gonna work, is it? You gotta have it. Okay. What about the routers and switches? Majority of everybody here has a router in their house, right? Some kind of router, right, or something. And why do you have the router? What's the reason? You have it because you want to hook up other things to it within the house. Does anybody have a MIMO switch? Router? You know what that is? Multiple inputs where you have, okay, so it covers a big area and you have multiple things going at one time. A lot of routers have up and down, like 2.5, and I need to look at my look at mine, where you can go up or down. Y'all have that on y'all's routers where you can go up or down? Like if somebody wants to stream, if you want to give all the bandwidth to that one person, I can hit a switch and I can give it to them. You guys have that? No? Okay, well they have routers out there that you can do that. Your routers that you should get should be something that you can control with your phone, on your phone. Like I said, if people don't want to get off your network, you can click a button, shut them down. Okay, So again, and we'll get into routers later, but not too deep, because this is not a Cisco class where we get way into the routers and stuff like that. I'm just going to point out to you some things that you need to know for the past, but routers can be we could talk about a router for a week. All the different things that it can do, all the different kind of routers, all the different things that it can do. What kind of router are you looking for? What size router are you looking for? What makes you pick this router over that router? All kind of questions. But again, this application layer, presentation, session, transport, network, and data link, and physical. He gave you guys, please don't nap today's session, please. Anyways, I don't know. I just made it up as I was talking. I know it didn't sound right, but anyway, you guys got your way of remembering. So I just wanted to let you guys know, if it works for
You
you,
gonna mess up
that's
Stephanie's
fine.
pizza.
Yeah, Stephanie's Pizza. That's it. Please do not throw Stephanie's Pizza away, right? Is that it? Please do not throw Stephanie's Pizza away. All righty. Let's move on. Okay. So we're going to talk about a bridge without even talking about you got the definition here, right? But really, what does a bridge do not even in technical terms, just what does a bridge do? Everybody's been over a bridge. What does it do? It does what?
It connects.
Go ahead. Go ahead,
It's
Vince.
two different areas. Oh, I'm sorry. Go ahead, Stephanie.
No, we were saying the same thing. It's fine. That we connect. I'm gonna say my answer and Vince's answers. He said we connect different areas. Right.
So in networking, what does it do? Same thing, right? It bridges the gap, right? It bridges the gap. That's what it does. That's what a bridge does. It bridges the gap. One side needs to connect to the other side, so it bridges the gap. That's what a bridge does. Okay. And as the definition says, network bridges are smart devices that process and record information about signal traffic between devices in the network. And that's exactly what it does. That's what a bridge does. Okay. And the way, like I said, on the exam, you really can't get the bridge mixed up, because it's really not too many other ones do what a bridge does. Okay. And here's a example. This is just a slide that I put up, and you guys see in the middle, what do you guys see? A router, right? That could be a router, couldn't it? In the middle, right? Well, yeah. Oh, I can't point to it, but the thing in the middle could be a router. It looks like a router, but it's a what? What is it? It's a bridge, right? So you have PC 1, 2, 3, 4, then you have a server. Okay. So the PC 1, 2, 3, and 4 are trying to get the information so the bridge can bridge the gap so they can get contact with that what? Server. Do you think they could contact the server without the router being there? You think they could do it? It has to be connected to something, right? A port or something, right? And this is what the bridge does. Okay. Now, what's the difference between a bridge and a switch? Anybody know? What's the difference?
The switch is going to have the ports controlled, and you're putting the firewalls on there.
Okay.
And switches to networks.
Okay. Yes. Okay. Now, hold on one second. Okay, this right here, can everybody see that? This is a switch by Linsky. right? This is a switch that I have to do different things. Okay, this is just it's an 8 universal port for the fastest connection on a variety of wire devices. So this is this right here is a switch. Okay, it's an 8 port switch. Now, to use this with a switch, sometimes you have to go in and configure it for it to work. Okay, now at work, you know, we have programs that we go in and we can configure the switch. You can do the same thing with this one. Okay, this is just one type, but there are different types. Okay, this is a Linksky switch. They got, you know, they got different. It just depends on what you're trying to do. All right, I just wanted to show you that. All right. Okay, so here's what a switch does. You guys already said it. Mine is a multi-port switch, which it has, like I said, I have 8 ports to it. Okay, so I can hook up what, 8 different things, right? 8 different things. Okay. All right. Now, as you can tell, a switch operates speed are very fast. Switches are also full duplex devices that allow digital signals to flow simultaneously in both directions. So that means it's going in both directions pretty fast. Okay. So you have a you have a switch and you have a bridge. So, in your opinion, what is the difference between a switch and a bridge? What's the difference? All right. That's something that you have to figure out. You have to do it in your own words. So, in your own words, tell me what a bridge does. The difference between a bridge and a switch. Anybody? I think Vince, one of y'all said a switch. I think it was you, Vince, right? Talked about the switch, what the switch does.
I said it had different multiple ports, and then the firewall's attached, or you can
configure it.
Establish a protocol for firewall there.
Correct.
On the ports.
Correct. That's correct.
I think John said it's connected to the net.
Yeah. Yep.
So can I see that definition again for the bridge?
Yes, you can. You surely can. There you go.
See, I see now. So bridge is really, a bridge is a deciding factor, really. It looked like the bridge is just, it's recording information or data that it was saying, and then now I'm just selecting the best path for you to take, according to what it's saying there.
Mm-hmm.
So the whatchamacallit is not doing that.
So, okay, so you know, with the switch, with the bridge, you know, the main thing is it's a hardware device, right? That or software that is used to join 2 separate computer networks to enable communications between them. So it bridges, just like when you go over a bridge, you go from this side to this side. Without that bridge, you can't connect, right? Like you go from one island to the other island, they have to have a bridge, of course, or a boat or something. But in this case, the bridge is acting as that. Without this connecting to this, it's not going to work. All right, that's what a bridge does.
Yeah, but I mean, they use the same thing, sir, and they use the same thing inside of the switch, that it's a type of bridge. The only difference that really is that one of them is recording information on data and stuff like that, and selecting the best path in which the data should be transporting through, versus in that switch and stuff. It's several ports will allowing information to travel in both directions.
Mm-hmm. Like a hub, a network switch is a device that connects network hosts. However, unlike a hub, a switch has a degree of intelligence. And everybody knows that a hub is stupid, right? I mean, if you don't know, the hub sends stuff where it just sends everything out. But a switch is going to direct where it needs to go. Everybody got me on that? a switch is going to direct where it needs to go. A hub sends it out, and we'll talk about that later. Then the bridge is the connector. It's the connector. Okay. All right. Everybody good on that? Just want to make sure we got a good understanding. Okay. Oh, let me go. I'm going backwards. Okay. This is a switch. You know, I showed you the switch that I have. This is a multi-layer switch. But again, like I said, the two on the end, you don't count those two because those are what you use to connect your computer up to try to get in and configure the switch. All right. So this one is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Okay. So this is just a switch. Okay. Okay, we talked about a hub. This is what a hub does. Hub is an idiot. It's the dumbest thing, but this is what a hub does. Okay. And then you see it says it automatically rebroadcasts any signal or data that is received from one device to all other devices on the network, because all the devices connected to a hub are competing for media usage. So you see it doesn't care, it just sends it out. Even though it doesn't need to go to this, a hub doesn't know that, it just sends it to everybody. So a hub is not really smart, okay, compared to a switch, right? So if you see something on the test that says which one of these is not very smart, they're going to word it differently, but you're going to know exactly what they're talking about. Okay, the difference between a hub and a switch. All right. This is a hub. This is a picture of a hub. This is another diagram. Okay. All right. Okay. Just want to bring it home a little bit. All right. A flood guard. I'll let you read that. So with the flood guard, exactly what it says: protects against denial of service. Does everybody know what a denial of service attack is? What it does? Remember we talked about it. A denial of service deals with what? What's the difference between a DOS and a DDoS attack? What's the difference? One uses one, and the other one uses multiple. And then it slaves. It makes them dummies. Okay. So the flood guard protects against that. That's his main mission, to protect against the denial of service, a SING attack, or a like I said, DOS. So like I said, the flood guard is the thing that protects against the denial of service attack. And remember what I told you about the DOS, denial of service attack is one of those things that it happens all the time. Okay. All right. So what you want to know about a flood guard is exactly what it says: protects against denial of service. All right. Everybody got that? Protects against denial of service. All right. And a SIN attack. All right. So if you have a SIN SYN, then you have an ACK. What's the ACK mean when you're talking about on the network? So you have SYN, then you have ACK. You know what I'm talking about? Okay, ACK is acknowledged, the other one is SYN. Well, I'll show it to you later. Okay, I'll show it to you later. All right, this is what a flood guard does. All right. Here's what port security does. Here's what port security does. I had told you guys about port security earlier in the class, where when port security is turned on, if your computer doesn't belong on that port, then the port will probably shut down and you're going to have to get the port reopened. All right. Port security, when we turn port security on, if your computer is for that port, nobody else can plug into that port. Everybody got me? That's what port security is. Okay. Okay, you see at the bottom, you can limit the number of MAC addresses on a given port. I only want one, so I'm going to limit it to that just one. All right. So again, it helps secure the network by preventing unknown devices from forwarding packets. When a link goes down, all dynamic lock addresses are freed. Okay, so you know what the difference between a static IP is? Okay, so you got static, and then you have, what's the other one called?
Dynamic.
Anybody know? Okay, so what's the difference between the two?
Static is basically, well, basically for the most part, static is just a written, it's set and
set.
Yep.
Correct.
Dynamic is when basically DHCP server gives it an IP address automatically without it having to be set.
Okay, so then with that being said, because when you have on the secret side, when we use the computers on that side, they are static. Then you have printers that are static. Anything that's static, that means that it belongs to just them, nobody else. Everybody got me on that? That's why I just want to make sure you know the difference between them. Okay, all right. Okay, this is in your book. All right, and these are different types of attacks in the descriptions of them and the security defenses. This is in your book. I'm pretty sure this is in your book. I just put the slide up there. This is on page 240. Okay. Now, if you look all the way to the right, you see security defenses for it. How do you stop these things from happening? Okay, just if you look at the bottom, port mirroring, where it says secure the switch in a locked room. Okay, then you see ARP poisoning using ARP detection appliance. Then you see MAC address spoofing. Configure the switch so only one port can be assigned per MAC address. So what does that mean? When you're configuring the port so nobody else can, only that one can be on that port. Nothing else can be on that port. And it really does cut down on MAC address spoofing. And like I said, the reason why they talk about MAC address spoofing so much is because it happens a lot. Okay, just like MAC flooding. Okay, and you see an attacker can overflow the switch address table with fake MAC addresses, forces it to act like a hub, sending packets to all devices. And when something is flooding, that means it's being overran or overfilled, or it can't handle what's being sent to it. And that's what a flood does. All right, so in this case, like I said, with the MAC addressing, when it turns it into a hub, you know what a hub does? It's going to send everything out to everybody, no matter if they need it or not. It's not like a router or a switch where it's going to say, hold on, we don't need to send it out this way. We only these people need to have it. Not all 10,000 people, only these people. But a hub doesn't do that. Okay, and the defenses against it, use a switch that can close ports with too many MAC addresses. Okay, so again, these are the different kinds of attacks. Now, what do you need to know on this? What you need to know about this slide is be familiar with the different kinds of attacks. Now, again, when you get ready to see this on the exam, right, you're going to see MAC flooding, MAC address spoofing, ARP poisoning, and port mirroring. Now, it might only be one question or two questions with all of these on there. When you look at it, you have to make sure that you know the difference between each one of these. So you have to figure out a way with the MAC flooding, the MAC address spoofing, ARP poisoning, and port mirroring, how to figure out a way to determine which one goes with which one. And the way I learned how to do this is practice, practice, practice. Okay? I'm just going to tell you how I did it. I used flashcards. That's how I got through it, okay? I practiced. When I took the exam, I studied for two straight months, 4 hours a night, and till I knew that I was ready to take the test. So if anybody put a card up or gave me a definition, I would know how to apply it. That was just me. Some of you might go in there, study for a week, and be ready to go, right? And I've seen it happen in my class, where some people come in and they just grasp the information and they have no problem sitting down doing the exam. They have no problem. Okay, so again, this is on page 240. Make sure you highlight these and know these, okay? All right. Now, this is our favorite one. Everybody knows what this is. Everybody knows what a router is, right? Everybody, and I'm not going to beat this up. I'll let you read it, but who doesn't know what a router is and what its functions are? Who doesn't know? Everybody knows, right? Everybody knows what a router is, its functions. All right, so I'm not going to beat it up. I'm just going to leave it for your for y'all's interpretation as far as. Now, can you get a router and a switch mixed up? How about a router and a hub? Okay. Okay, good. What about a router and a bridge? Can you get them mixed up? Okay. So a hub, you definitely can't get it mixed up, right? You definitely can't get the hub and the router mixed up because the hub is stupid. All right. Again, everybody have a router in their house, some kind of router in their house that they use, right? I also have, this is, like I said, this is my switch, and then this is, so everybody's good with the router. I'm not gonna beat it up. Everybody pretty much knows what a router does. Is it layer 1, layer 2, layer 3, layer 4? Which one is it? Layer 5, layer 6? Which layer is it? Which layer is a router? Layer 3? 2? Can it be both? Can it be both?
I'm gonna go with yes.
Just 3. Switches is both.
Huh?
Switches can be 2 and 3. Routers is 3.
Yep. Routers is, and that's on page 241. Okay, I said that because I want you to make sure you know that. You understand? Okay, so just make sure you know that, okay? That's why I kept saying it again. And it's on page 241 also. It's on page 241. All right? Okay. Here's a router. This is just an example of a router. Pretty cool looking router, right? What do you think? What y'all think? Think it's a cool looking router? Think it's worth the money? What about all those antennas? Think it's worth it? Who has a router that has a lot of antennas on it? Any of you guys? Or what kind you got?
I think it's called like a Nighthawk or something like that.
Nighthawk. Okay, how many antennas? 6?
I think it's 3. I think.
You got 3? Okay.
Yeah.
Okay, so anybody else got a router? That nobody? Okay. Okay. I see you, Vince. All right. This slide in this router, right? Bam! There it is. Yes, sir. There it is. Woo! Yes, sir. Actually, what I did was take a picture of my router and put it on the slide. There it is. The pit bull. It looks like a pit bull. It's a pit bull router. It does. Okay, so the reason why I picked this router, right? Because it's a MIMO router. It's a next generation multi-user MIMO technology where you can do all kind of things to it, and it's pretty high speed. I can control this router. With my phone. Like I said, I can cut people off. It can go up or down. Okay, so it's pretty good router. All right, it does a whole lot of things. Now, of course, I have configured my router to do certain things. I went into the router and did some things to it, and you can do the same thing. But if you mess up when you're doing stuff with the router, just don't save any of the stuff you did. Because if you do and you forgot what you did, all you gotta do is reset it. That's all. Okay, so that's why I put this router up. Let me show it to you one more time. Bam, there it is. Woo, 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 woo. That's the router. Yes, sir. Okay, so I just used the picture because it's my router, right? All right, thought you'd get a laugh out of it. Okay, now let's talk about a load balancer. What does a load balancer do? What is the main reason that we need to know about a load balancer?
Basically, it just loads or balances the load of the servers, depending on, I guess, how it's used. It will just bounce it off. If a system or a server is getting more, I guess, of the load, it would just kind of even it out, spreading out exactly which system gets, I guess, I don't know, how much traffic or how much work, kind of just, yeah.
That's exactly right. It balances the load. It makes sure that nobody is overran. It makes sure that everybody is equally balanced out. It's not going to overload anybody. It's going to make sure, and like I said, with this, you just want to make sure that this is set up where it's going to balance the load. That's what you need to know about a load balancer. It's going to balance the load. Everybody got me? That was a perfect definition, okay, for it. All right. It was a good definition. And in the book in chapter 6, on page 241, at the bottom, it talks about a load balancer. So you can refer back to that if you like. But again, that's exactly what it does. It balances the load. Okay, it balances the load. All right, good deal. Any questions so far? Pretty self-explanatory, right? Pretty good. All right, so let's move on. All right, we're moving on. Here's an example of a load balancer. Okay, and this is what it does. Okay, you see, if you follow the diagram and you see where it says the client's request, and the load balancer makes sure that he forwards it equally amongst the machines. Okay, everybody see that? It's just want to give you a picture of what it looks like. All right, the client is you, and the load balance make sure that it forwards the request evenly. Okay. All right. And the slide is not in the book, but the load balancer section is in the book, and it's on page 241, and it goes to page 242. Okay. All right. Let's talk about the next thing. Any questions so far? Pretty. Remember, a load balancer balances the load. Load balancer balances the load. You as the client sends it to the load balancer, and the load balancer balances the load. Okay. All right. Here's the proxy service. Here's what a proxy does. Okay. Now, with the proxy service, what I want you to key on is what it says it's an intermediary role played by software or dedicated computer system between an endpoint device and a client. All right, what is the endpoint? When it says endpoint, what are they talking about? What are they talking about? The endpoint. You have the client. Who's the client? You or your system? You're the client. Okay, so the endpoint device, what is the endpoint device? What is that? What is the endpoint device? What is that called? Anybody know?
I could guess.
Web page.
Go ahead.
Web page. Or where you're wanting to go from the client to the, the proxies are taking the request and sending it to the server, and then the server goes out and tags the web page and then comes back.
The endpoint, exactly. That's correct, Vince. Everybody got that? That is correct. That's correct, Vince. Exactly correct. All right. That's exactly correct. Okay. So you as a client, which is the request in the service, you have the proxy is between, and then he does what he does. You're the client, proxy, and endpoint. Okay. So that's why it says it's in the middle. It's in the middle. Everybody got me? It's in the middle. Okay. Vince, that was a good answer. That was good what you said. Okay. All right. Uh-oh, hold on. Oh, okay. So here is the proxy services. There's two types. You have a forward proxy and a reverse proxy. I'll let you read it. Okay. Now we'll get into these. We'll get into the forward proxy first. All right. And here is the forward proxy, which we were just talking about, but here's what it does. I did a little bit more deeper. And it's interesting to look at where you see usually the word forward is dropped and is referred to simply as proxy. This is the case in Microsoft topology. Interesting, huh? Okay. Any questions on this? Anybody? Okay. All right. So let's move on. Here's just a diagram of a proxy. Just a, and you notice Microsoft, they just say proxy. You know, they take off the forward proxy. All right. So the people on, who are the people on the left? Who are the people on the left? They are who?
User.
And then the person in the middle, the one in the middle is who?
The proxy.
The proxy. And then the proxy is the person that's between, he's between the client. Then you have the proxy. Then what do you have?
Internet.
And the internet. And then what goes to the internet, what is it doing?
What is the server?
It's forwarding it to the internet. And the internet is sending it out to find out, forward it to wherever it needs to go. Everybody got me on that? I try to put that as simple as possible. So you have the proxy is in the middle. The proxy is forwarding it to the internet. Internet is sending it out to the different servers. Okay? Everybody got me? Any questions? Okay. So you're the client, you got the server, the proxy, and then you get the internet, and it's going to send it out. All right. Okay. And remember, you have the forward proxy and the reverse proxy. So if you have the forward proxy, and then the opposite of that is the reverse proxy. This is what it does. Okay. Now you have the forward proxy, and now you have the reverse proxy. What's the difference between the forward proxy and the reverse proxy? In your own words, what's the difference between them? If you got asked this question, could you say what the reverse proxy, the difference between the forward proxy and the reverse proxy is? Anybody? If you got the question, could you say which one is which?
The forward proxy takes information from the client and sends it out to the web server. The reverse proxy takes it from the web server and sends it to the client.
Everybody agree with that? Everybody agree with that? Vince, you agree with that, Vince?
Well, you can also say encryption too. So encryption and decryption. So the reverse proxy does decryption.
Okay.
Okay.
I believe.
Okay. Anybody else?
The reverse would encrypt the data from the web server.
Go ahead, Vince.
Going forward, the front end proxy would encrypt it, and then as it goes through and goes, when it hits the reverse proxy and it sends it back, it should decrypt it, if I'm understanding it right.
And then because it's going to send it back to where it originated from. You said the same thing. He just talked about the encryption. Say you said both of you guys are saying the same thing. Vince just added the encryption part of it. Okay, so that's correct. That's correct. Okay, so we have the forward proxy, and a reverse proxy. Those two, know the difference between those two. How to explain it? How to look at it on a test question and understand what is it asking? Is it saying the risks? I mean, the forward proxy or the reverse proxy? Which that answered what you guys gave us pretty good, pretty on. Okay, pretty good. All right, here's an example of which we just talked about it. Okay, it's the same thing you guys said. This is just a slide. That's all it is. Okay, it's just a slide that I wanted to break it down a little bit better. But both of you guys got the right answer. This is just a slide for you. Okay. All right. I'm not. This is just a. And if you look at it, it's saying the same thing that you guys said. Right. All right. Okay. All right. Here are more types of proxies. This is just information that you need to know. I haven't seen these are on any exams, but you just take a look at these and just take a look at them and just different ones. But the main one you're going to need to know is the reverse proxy and the forward proxy, okay? The reverse proxy and the forward proxy, okay? This information. Now, and like I said, the transparent proxy does not require any configuration on the user's computer. It is often used of content filtering in schools and libraries, okay? In schools and library. And you can use it, a proxy server on the internet connections, you know, with the VPN. Does anybody use, okay, let me ask y'all this. Is anybody working from the house right now? Everybody's going to work? Or okay. So for 3 months, off and on, I was working from the house. And I would VPN in and I would have to remote into other people's computers or networks, right? And the way I did it was I would remote in to my desktop computer at work. And then my desktop computer, I would remote into that one, and then I would get into that computer. Then I would act like I was actually in the office, and then I would go out to wherever I need to go out to do the computer to fix the problem. So now, with that being said, right, the way we did it was with the VPN, right? Now, let me ask you guys something. Can you get VPN on your phone? Can you get VPN on your phone? And why would you need VPN? And it's VPN secure. Anybody know?
You can still VPN to obfuscate your IP address.
Yes, correct. That is correct.
That's correct. I did it from when I was in Kuwait from my phone, since I was trying to connect to just local internet there they had, and I knew it was going to be watched by everybody. I would just connect into a VPN tunnel.
Correct.
And I could talk back home or go to a website without the IP address, thinking it's coming from where I'm at, and it was coming from Germany or Norway or France or wherever.
Correct. That is correct. That's correct. So you have the transparent proxy, then you have the anonymous proxy, then you have the high anonymous proxy. So you see where the first one, anonymous proxy, hides the IP, and that's what Vince was talking about. Okay, then you have the high anomaly proxy, right? It hides even the fact that they are being used by clients, and that's a pretty high tech one. I mean, you don't want to you don't want nobody to know nothing about you, nothing. Just like a hacker, when you hack into a computer, if I hack into your computer, I have the ability to back out of your computer without you even knowing I was on the computer. Because as soon as you log into a computer, it what does it do? it has a log and says, computer log that says this person logged on to the computer at this time. But if you're really good at what you do, you can have it where you can go into the computer and then it's like you were never there. Okay. And again, these kind of proxies or the one at the bottom is that's what they're saying. All right. So you got the transparent one, anonymous, and the high one. Okay. Good information to know. And this is on page 244 of your book. Okay. All right. Now we're going to talk about, all right, firewalls. Everybody knows what a firewall. No, let me digress a little bit to make sure. Who does not know about a firewall? Everybody knows what a firewall does. What its job is to do what? Block, right? And however you set up your firewall, you set up your firewall to block certain things, right? You control the firewall. If you want this to come in, you let it come in. If you don't want it to come in, the firewall says, hey, you're not authorized to come. You stop at this point right here. You can't get past this wall. All right? You set all that up. You're in charge of that. You make it happen. Okay? Do you guys, who has Norton on their computer or some kind of software on their computer that they set their firewall? And you can set the parameters. You can set up the way you want to block or detain or whatever you want to do. It's really up to you. Okay. And you see that it may be implemented using hardware, software, or a combination of both. All right. Here's what a firewall does. This is just a little slide of what it does. Okay. And it's everything that we just talked about. It's gonna say this traffic can go through, but this traffic can't. You set that up. Your firewall, you set it up the way you want to. On the government side, the firewall set up, and they know exactly what they're gonna let through and what they're not gonna let through. Okay. So on the exam, you just need to know what a firewall is, what its position, why do you need a firewall, and what it does. Okay. All right. Okay. All right. Now this ones that I'm going over now. This high base firewall, host based firewall. Now let's look at this. I'll let you read it real quick. Okay, you got the host-based firewall. It's talking about what host-based means. Who? It means who? It means we talk about host-based firewall. What is it talking about? It's talking about a work environment, or it's talking about a home environment. What is it talking about? Go ahead, Vince.
It can be either.
Okay. Okay. All right. So when you think of a host-based firewall, right? Are you the user, the host, or is somebody else the host of the firewall? Go ahead, Vince.
Which your system, your computer.
Exactly. Anytime you see host, they're talking about you. Okay. Anytime you see, I want you to get this. Anytime you see hosts, they're talking about you, or your equipment. Okay. All right. Host-based firewall is talking about your system or device connected to the network. So host-based is something that you own or control of. All right. So let's go on. So everybody got it? Host-based firewall. Okay. Here's the advantage of software, firewalls, and here's the disadvantages. It's information that you should know. Okay. And these are, like I said, these are some of the advantages and disadvantages of a firewall. How many firewalls do you have on your computer? How many? How many firewalls do you have on your computer? 1, 2, 3, 5, 10, what? 20, 30, what? Go ahead, Vince. Yep, that's all. That's all you need. Okay, that's all you need. All right. This is just some of the advantages of the software and some of the disadvantages of the software. Okay. Just want you to know that. All right. Okay. Now, implicit deny. You need to know this. Implicit deny. You will see this again. You will see this again. You will see this again. So on page 248, you will see implicit deny again. You will see this again. Okay, I want you to key on block number 2, the bullet number 2, the statement focus. The statement forces the firewall to block any traffic that wasn't previously allowed on the ACL list. If you weren't on the ACL list, it's going to block you. Okay, if you're not on the ACL list, which is the access control list, it's going to block you. That's what implicit deny means. It's going to deny. If you weren't on the access control list, you're not getting in. Okay? You're not getting in. Okay? You're not getting in. Implicit deny means that exactly what it says. You weren't on the access control list, you're not getting in. Okay? Make sure you know this. You're going to see it again. This is on every exam that you guys take. Well, Security Plus. It's on there. Can't get away from it. It's there. Okay? So I want you to key on block number 2. Statement focuses on the firewall to block any traffic that wasn't previously allowed in the access control list. All right? So now we got the stateless packet filtering. You're going to have to know this too. Okay? You're going to have to know this too. And I have another, I just want you to read over this, but I have a slide that I'm going to show you. Okay? All right, so packets can be filtered by a firewall in one or two ways. Stateless packet filtering looks at the incoming packets and permits or denies it based on the conditions that have been set by administrator. Stateful packet filtering keeps a record of the state of connections between an internal computer and an external device. It makes the decision based on the connections as well as the conditions. So what I want you to look at, right, for this one, the stateless packet, let me go to the next, let me go here. All right, here's the stateful, here's what a stateful firewall does. This right here, you have to know, you're gonna have the stateful firewall, and you're gonna have the stateless firewall. Okay. Okay. This is on page of your book, on page 249. 249 in your book.
Can you go back to stateless, please?
Go ahead.
Can you go back to stateless, please? The definition once more.
Stateless.
Yes.
There you go.
Thanks.
You good?
Yep.
John, you good? You good? Okay.
I'm good.
Okay. And here's the stateful, which we talked about earlier. Stateful firewall. Okay. These two firewalls, the difference between them, you must know the difference between what one does and what the other one doesn't do. You will definitely see these again. Remember, the stateless packet filtering, it looks at the incoming packets and permits or denies based on conditions that have been set by the administrator. And the stateful packet filtering keeps a record of the state of connections between an internal computer and an external device, and then it makes the decision based on the connection as well as the condition. Okay, these two definitely need to know these. Definitely need to know them. All right. Okay. Now you have, not only you have the stateless packet filtering, then you have the stateful packet filtering. Now what else is coming? Now you have the application firewall. Application firewall. All right. You have the application firewall. I'll let you read it real quick. Now you got the application firewall. What level? What in the model, OSI model? What level is the application firewall?
7.
Good, correct. 7. That is correct. Okay. Now you have an application firewall. You have two types of application firewall. We're going to hit those real quick. All right, here they go. I'll let you read over them. Okay, as you can tell, you got one that's network based and one that's host-based. So when you see something that's network-based firewall, it's talking about what? Talking about what? It's talking about the network. When you see something that's host-based application firewall, what is it talking about? Local computer. Host-based is dealing with a local computer. Network-based is dealing with a network-based computer, the network. So when you see these two, anytime you see something that's with the network in front of it, it's dealing with the network. Anytime you see something dealing with the host, it's dealing with a personal computer. Okay. All right. So you got application firewall has two different ones, and you have the network-based, host-based. Network deals with the network one, and the host-based deals with the host-based computer, which is a local computer system host. Okay. All right. Okay, here's the VPN. We talked about that earlier. What a VPN does. The name exactly talks about what it is. Virtual private network. Okay, it's a private network. Allows VPN users to securely access a network from different locations via a public telecommunication network, or most frequently the internet. Like when I remote in from the house, I'm on a VPN. It's secure private network. Okay, secure private network. That's what a VPN is. All right. Here's what a VPN concentrator is. All right. Okay. And the VPN concentrator is on page 251, but this is what it does. It's a type of networking device that provides secure creation of a VPN connection and delivery of the message between the VPN nodes. So it's like a delivery service. It's going to make sure that it secures creation of the VPN connection. Like I said, it's a delivery of messages between the VPN nodes. The different nodes that are out there, it's going to make sure that it talks to them securely. Okay. Okay. All right. It's going to make sure that it sends it out to the different nodes on the VPN to make sure that it's secure. Okay. All right. VPN concentrator. That's what it does. All right. VPN concentrator. That's what it does. Okay. All right. Here's this is just another slide that I have for a VPN concentrator. Okay. It has the ability to create and manage a large quantity of VPN tunnels. A large quantity. That means a lot. A lot. It has the capability of being able to create and manage large quantities of VPN routing, VPN tunneling. When you think about site to site, we're talking about from one site to another site, and this is all the things that it can do. All right, this is what it can do. It can do all these things. Right? Well, you need to know all this. No, what you really need to know is what a VPN concentrator is and what its function is. Okay. what its functions are. Okay. All right, let's move on. Okay, everybody knows what, let me say this. SMTP, POP3, IMAP. Know the difference between these three. All right, so you got a POP3, you got IMAP, and SMTP. All right. Everybody's familiar with these ports, right? Y'all should learn these ports in networking, correct? SMTP, POP3, IMAP, especially POP3. Okay. Okay. All right. So you have the simple mail transfer protocol, SMTP, handles outgoing mail, while the post office protocol, POP, most commonly known as POP3 for the current version, is responsible for incoming mail. So you have SMTP, outgoing, POP3, incoming. Okay. And then in the more recent and advanced electronic email system of incoming mail, while POP3 is stored and forwarded service, IMAP is a remote email storage. IMAP, the email remains on the email server and is not downloaded to the user's computer like POP3 mail. Okay. So IMAP stays on the server and it's not downloaded on the computer. POP3 is downloaded on the computer. SMTP forwards. SMTP is it forwards the outgoing mail, and then the POP3 gets the ingoing mail, and the IMAP is downloaded, not downloaded, it's on the server, so it doesn't download on your computer. So remember these three: SMTP outgoing, POP3 ingoing, IMAP is for it stays on the server. Okay, and it's a more advanced. Okay, out of those. All right. Okay, here's the difference between inline and passive. IDS. Can anybody tell me what IDS stands for? Can anybody tell me what IDS stands for?
Intrusion detection system.
Intrusion detection system. You think you have inland versus passive IDS. So you have passive. When something is passive, what does that mean? When something is passive, what does that mean?
It's not active.
Not active. It's just like, oh, I'm here today, and it's just okay. It's not active. It's just okay. I'm here. And one thing about a passive IDS, it can cause false alarms. You know. All right. So here are the functions. You got connection, traffic flow blocking, detects errors, directly to the network, routing through the device, can block attacks, may disrupt services. Passive connects to the port and switch, receives a copy of the traffic, cannot block attacks. It can't do anything because it's passive. It's just like, oh, okay, I'm here. But an inline one can do what? It can block attacks. It may disrupt services, and it's directly to the network. So remember, the difference between passive, it ain't going to do nothing. It's just going to say, I'm here, and it's going to let everything happen. But inline, it's going to say, wait a minute, it can block attacks. So intrusion detection system is passive and inline. The passive one doesn't really react to anything. It's just there, kind of like a placeholder. Okay. All right. So what I'm gonna do is right now it is. I know I've been talking for a while, man. I get caught up on this stuff. It's 7:30. So let's do 15. Everybody good with that? Everybody good? Let's do 15. We'll come back at 7:45. Everybody good with that? And then we'll come back and we'll knock this out, okay? All right. So 7:45. All right. All right, you guys ready to get started, finish, get this done? All right, we left off at inline passive IDS, intrusion detection system. Passive IDS is exactly what it is. It's passive. It lets you know it's there, but it doesn't do anything. Inline, on the other hand, it may disrupt services, can block attacks. It does something. Passive doesn't do anything. It's just there. Okay, so you want to know, like I said, intrusion detection system. Between the two, the passive one doesn't do anything, and the inline does something. Okay, that's the difference between the inline versus the passive. Okay, make sure you know those two. All right, make sure you know those difference between them. Anything passive is exactly what it is. It's not going to do anything. It's just, oh, I'm here. That's it. All right. Okay. Now, these right here, monitoring comparison of the trap port scanning applications, you got to know these. You have to know these, and they're not too hard when you really think about it. They're not too hard to really remember. Okay. If you understand what the definition of anomaly is, signature, behavior, heuristic, monitoring, if you really think about this, when you think of an anomaly, what is that? When you think of an anomaly anyways, what is an anomaly? What does it do? What is an anomaly? When you think of an anomaly, what is it? What is it? In your own words, what is an anomaly?
Something out of the ordinary?
Out of the ordinary. Out of the ordinary. Anomaly is out of the ordinary. Okay? It's out of the ordinary. Then you have a signature. When we think about a signature base, what are you talking? What are you talking about? Think about it. You got the anomaly that it's out of the ordinary. Doesn't always happen, but it happens. So it's like, oh my God, it happened. Now you have a signature-based monitoring. When you think about a signature, that means it's leaving what? Something behind. You get what I'm saying? Y'all follow me? When you have an anomaly, it's something that happened. It happened maybe once in a lifetime or whatever. But then you have a signature. It always leaves something. How do you know that? How do you know that this is who it say it is? Because it leaves a signature behind to let you know that it's this, whatever this is. That's its signature. Like for example, if you are a person that plays cards and your signature move is you in spades, you slap the person across the head with the queen of clubs. That's your signature. Every time you play a spades, you slap somebody across the head with a 10 of spades. That's your signature. Everybody knows you by that. Everybody knows the signature by that, whatever that signature is, okay? Now, you have behavior-based monitoring. It's known by its behavior. It's known by its behavior, how it behaves. It's not the same thing as anomaly. It's not the same thing as a signature, but a behavior is how it behaves. It behaves a certain way, and you know that this behavior is a behavior-based monitoring, okay? And then you have heuristic. IDS is triggered if an application tries to scan multiple ports. So, like I said, with these, you need to make sure that you understand the difference between, and I'm gonna hit each one of these, but I just want you to, especially this slide right here, make sure you know every one of these, every single one of these, what they are. You know, the anomaly, the signature monitoring, and the behavior. Make sure you know the difference. I can't stress this enough. You have to know the difference between these three. I mean, these ones, okay? You have to know these, all right? You have to know these, all right? So anomaly doesn't always happen. Signature based leaves a signature behind. Behavior, it behaves a certain way. And then heuristic is, it's an application that tries to scan multiple ports, okay? All right, so let's move on. Then you have anomaly monitoring. False positive, you got to know what the difference between a false positive and a false negative is. What does a false positive tell you, and what does a false negative tell you? I'll let you read it. Okay. And the slide that I had up there is on page 256 about the monitoring methodologies, anomaly-based, signature-based, and behavior-based. Okay. Okay. Now, you see the difference between a false positive and a false negative. When something's a false positive, what is that telling you? When somebody says it's a false positive, what does that mean? To you, what does a false positive mean? In your own words.
Yeah, or at least there's not an actual threat.
There you go. It's not actual, so it's a false positive. It's not an actual, it's not an actual. So then if you have a false negative, then what does that mean? You got a false positive. Go ahead.
Sorry. It just means basically that a threat wasn't detected.
But it wasn't detected, but it was a threat, right?
Yes. Oh, yeah.
Okay. Okay, so you guys make sure you know that the false positive, what the false positive is and the false negative is. Okay, make sure you know the difference between and these two. So in other words, a malicious activity is not detected and alerted, false negative. It happened, but it didn't do anything. It didn't, but it was there though. Okay, then you have the false positive that says there was something there and there was nothing there. It's kind of like the opposite, isn't it? All right, so false positive, false negative. You got to know these. You got to know these. False positive, false negative. You're gonna see these again. False positive, false negative. False positive, false negative. You're gonna see these again. Can't stress enough. You're gonna see it again. All right. So now we had talked about intrusion detection system, right? So here is what a intrusion detection system is. All right, here is the definition of it. All right. Everybody got that intrusion detection system? All right. Intrusion detection system. That's what IDS is. That's what it does. Intrusion detection system, type of security software designed to automatically alert administrators when someone or something is trying to compromise information systems through malicious activities or through security policy violations. And IDS works by monitoring the system. Number one, there you go. It monitors the system and actively through examining vulnerabilities in the system. By checking the system out, it's going to see if there are vulnerabilities in the system, and then the integrity of the files and conducting an analysis of patterns based on already known attacks. So again, the IDS is a type of security software designed to automatically alert administrators when something or someone is trying to compromise information through malicious activities. So with that being said, you know what the IDS is, but you have three primary components of the IDS. And three primary components of the IDS are these. You got the network intrusion detection system, you got the network node intrusion detection system, and you got the host intrusion detection system. Now, without looking at the definition, which one of these deals with the host? Remember when I told you about the host? The host deals with what? Remember I told you? It deals with what? Go ahead, Dennis.
HIDS.
Okay. So it deals with when you talk about a host intrusion detection system, the heads, right? What do you call it? The heads. What is it? What is its main mission? And compared to the host intrusion detection system, compared to the network intrusion system, what's the difference between those two? What's the difference between the host and the network intrusion system? Let me know. Somebody tell me. What is the difference between the two?
It monitors and compares missing
Okay.
files.
Okay. So what's the difference between, okay, both of them monitor, but what is the difference between the two?
Well, I just reading the definition of the host intrusion. All it's saying is that, hey, once when you talk about when the system file set comes in, it just monitors what it actually looks like and what it compares to what it was before. So if any kind of differences between the two of them, it starts alerting you because something is different about it.
Okay.
It has
So
a
what
baseline.
about
It compares to a baseline.
okay, there you go. So then it compares to a baseline, but then what's the difference between the network intrusion detection system?
It says it right there. It's doing analysis for the whole subnet.
The whole subnet. What subnet? What are they talking about?
Everything that's on that network that's connected to it.
On the network. See, what I want you to look at is network intrusion detection system deals with the network. Everybody got me? Everybody follow me on that? Anytime you see something that says NIDS or NPPS or whatever, it's most of the time it's dealing with a network. Okay, so when you deal with a host intrusion system, when you're dealing with that, what do you think it's talking about? A host-based intrusion detection system.
It's talking about your computer.
Talking about your computer. Remember I told you, anything dealing with hosts is dealing with your stuff. Anything dealing with networking is dealing with the network. So these two, you can't really get them confused. Just remember network and host. Network and host. Try to remember that because you're going to see this again. Network and host. Okay. Now, on top of that, you have the network node intrusion detection system. So what do you think that's dealing with? What do you think that's dealing with? The network node intrusion detection system.
Dealing with only one computer in the network.
They one of the keywords is single. One.
Right. One. But it's dealing with what though?
Single host.
Single host.
Subnet.
Exactly. So, but it's dealing with one, but it's also dealing with one on the network. So, exactly. I want you guys to get this because you're going to see it again. And they're going to put questions on there like this to try to mess you up. But once you know that, like I said before, you know the definitions and the objections of the course and how to apply these things, you'll be fine. So network intrusion detection system, network node intrusion detection system, and host intrusion detection system. I keep hitting it because you're going to see it again, you're going to see it again, you're going to see it again. Okay? You're going to see it again. So now we know about the intrusion detection system. So we talked about the intrusion detection system. Now we're going to talk about, guess what? The intrusion protection system. IPS, intrusion protection system. I'll let you read it. Okay, so you see intrusion protection systems, also known as intrusion detection system. All right, so the main thing about the intrusion protection system, as the name implies, an intruder prevention system, IPS, not only monitors or detects malicious activities like an IDS, but it also attempts to present them by stopping the attack. So you have the IDS, now you have the IPS. So you have the IDS, right? So with the IDS, what did the IDS do? What did the IDS do? Y'all remember what the IDS function was?
It's detecting malicious activity.
Okay. Now you have the Go ahead, Vince.
It's just detecting. So I would say, so for these two, it's kind of like that commercial where the cop's in the bank and he's saying, hey, I can't do anything, I'm just a monitor. There's a bank robbery going on.
Like a stick patrol.
Yeah.
I see you. I got my flashlight. I see you. Okay. I can't actually do nothing. All right. So what I need you to do is make sure that you know you got the IDS, the IPS. So one tries to do it, one tries to prevent it. The other one is like, oh, okay, I'm here, but I can't do anything. Y'all get me? So the difference between the two, one tries to do something, the other one doesn't. Okay. The one tries to do something, I want you to get this, and the other one doesn't. And Vince, that's perfect what you said. Good, good. Okay. All right. Now we have the host-based prevention systems. HIPS. Has anybody ever had to deal with HIPS before? Not, you know what I'm talking about, HIPS on the computer. Anybody had to deal with HIPS before? Okay. I deal with it all the time. All right. On the government computers, right? HIPS is on there. All right. It's like I said, it's a host-based intrusion prevention system that employs and protects critical computer systems containing critical data against viruses. All right. So what happens with HIPS? I have some software that I want to load on a government system, right? HIPS detects it and says that it's a virus. It's not really a virus. It's just HIPS says it's a virus because on its scan, whatever they set it for seems to think that this software has a virus. So HIPS stops it from loading. You try to load it.
Yep.
You try to load it and it blocks it. Okay. So then what I have to do in order to load the software, I have to take it out of the HIPS mode. Where I take it out of HIPS, I load the software, and then I put it back in HIPS, so I can load the software. If HIPS is set up where it won't let you do it, you're not gonna be able to do it. The only way you can get it done is you have to move it out of HIPS, out of it, kind of disable it, put it back in, and then set it up, and then it'll work. Okay, all government systems have HIPS on it, all of them. All the government systems has, actually when we do the image, we set the image up, all of it had HIPS on it, okay? And it's constantly monitoring, it's constantly, because there's software that the government uses that if you try to load it, it will block it. There might not be nothing wrong with that software, but because HIPS is set up to detect certain things, it can say that this software is malicious, but it's not malicious, okay? So again, all government systems have HIPS on them. Okay, I'm gonna say, when I say all, I'm gonna say Fort Bragg, where I work, it have it on there. Okay, but it should on nationwide. All right. Okay, HIPS protects from known and unknown malicious attacks. So remember when I told you host-based intrusion protection system. Host-based intrusion protection system. Got it? Host-based intrusion prevention systems. You had the host-based intrusion protection system, you had the intrusion prevention system, then you had the intrusion detection system. You need to know what's the difference between the intrusion detection system, intrusion protection system, and the HIPS, home-based intrusion protection system. Okay, those terms you will see again. So, like I said, when you're dealing with networking, intrusion protection system, you know what it is. Dealing with the network. Host-based is dealing with one computer. Okay, all right. Then you have the SIEM. I'll let you read it. Okay, you got with the security information event management software collects and aggregates log data generates throughout the organization technology. All right, so the software then identifies and categorizes incidents and events as well as analyzes them. The software delivers on two main objects. Here's what they do. Here's what it is. Here's what it provides. So this is kind of like information that you can use, isn't it? This is information that you can use, right? You can read the report and it says, it provides a report on security-related incidents and events such as successful and failed logins, malware activities, and other possible malicious activities. So this is good to know. So like I said, what you want to know about this is, it's good information, but this is you have to know. What I'm talking about now, all these things I'm talking about, is all going to be on there. Okay, this is stuff that it's so SIEM is like a log. It's like a log, but you got different kinds of logs. So with the SIEM log, it's different there's different kinds of logs. So you need to make sure that you understand what SIEM does, error log, security log, all that crazy stuff. All right, and we're going to hit all those. I don't know if it's going to be in this chapter, but we're going to hit all those. Okay. So remember, SIEM provides reports on security related incidents and events. And again, like I said, it's a consolidated real-time monitoring and management of security information with analysts and reporting of security events. Analysts and reporting of security events. Analysts and recording of security events. Okay. Key security events. Key security events. Okay. Key. Okay. Now we have other network security devices. I'll let you read this or look over it. And this is on page 259. Okay, media gateway. When you see media gateway, when you see gateway, what is a gateway? When you see gateway, what is the gateway when we're talking about the network?
Doorway.
Go ahead. Go ahead. What was that?
No, I just said, I hear gateway, I think of doorway.
Exactly. If you don't have a gateway, you're not going to talk to the outside world. Correct. That is exactly what it is. Okay. So we talked about SSL and TLS. All right. Everybody knows that TLS is taking over for SSL. All right. So a separate hardware card that is inserted into a web server that contains one or more coprocessors to handle the SSL or TLS processes. So exactly what it says. Now, will you see this? Will you see this? I don't know. You might see it. So it's something to look over, but most of the people don't see this. But I had to show it to you. All right. Then you have the SSL decryptor, a separate device that decrypts SSL. So anything that decrypts something, you guys know, you got to encrypt and you got to decrypt, right? Everybody knows the difference between a decryptor and a encryptor. So you see SSL and it decrypts SSL. All right. Now you got the hardware security module, a dedicated cryptographic processor that provides protection for cryptographic keys. All right. This stuff right here, you just have to know it. Okay. All right. There's really no other way to explain it. You just have to know it. All right. Now, again, with that being said, most of the people that have taken the exam didn't see this, but I have to show it to you. Okay. I'm not saying it's not going to be on yours, but I have to show this to you, okay? And this is on page 259, right? For further review, it's on page 259. And I think I have some questions on the practice exam that maybe that will help you really put this together, okay? All right. Then you have this Unified Threat Manager, Internet Content Filtering, Web Security Gateway. There's the gateway again. There's the gateway again. Internet Content Filtering. And then you had the UTM. You got to know what the UTM is. Okay. UTM. You got to know what that is. That's on page 260. Now, these three would definitely be on there. These three would definitely be on there. Anything that's, when you see content filtering, okay, you know what it's doing, right? Anytime you see content filtering, it's filtering the contents, isn't it? That's pretty much what it's doing, okay? When you see web security gateway, we already know what the gateway does, but when you add security to it, it's doing exactly what it says. It blocks malicious content in real time as it appears without first knowing the URL of a dangerous site. So web security gateway is exactly what it's saying. Okay, you already talked about the web, then you have the gateway, and now you add security in there. It's going to protect the gateway from security, from malicious activities. Okay, content filtering is going to filter and monitor the internet traffic, and then you have integrated unified threat management, integrates devices that combine several security functions. All right, these you need to know. These you got to know. Okay. All right, my favorite. I'm not gonna say my favorite, but when you think of DMZ, what do you think of? You guys, when you think of DMZ, what do you think of?
Korea.
DMZ. Korea. Who all did everybody get? Well, I don't know. I know I'm throwing it out there, but who all has been to Korea? Once, twice, TDY. I've been there 3 times, no, 3 or 4 times while I was in the military. And I was stationed at Camp Casey, which is like right there. You had Camp Graves. If the North Koreans came across, they would have to come across this bridge. So those guys would have to blow the bridge up so they couldn't get across. We were like 15 miles from the border. So we were like, if they get past us, then you're all in trouble. So that bridge was there to stop them from getting past. Then just like you see on TV where you have the Korean, the North Korean guy on one side and the South Korean guy on the other side, that's exactly how it is. One side of the building is on South Korea, the other side is on North Korea. Crazy, huh? But that's how it is. Okay. So I always bring this up because when people talk about DMZ, they talk about Korea. But in the IT field, when we talk about DMZ, it's a whole different, it's something different. All right. So you need to know what this DMZ does and what it's referring to. What is the DMZ referring to? And as the definition says, it refers to a host of networks that act as a secure and intermediate network or path between an organizational network and an external and non-proprietary network. It also serves as a frontline network that interacts directly with external networks while logically separating it from the internal network. So the DMZ is, you know, your book gives a pretty good explanation of the DMZ on page 260. But like I said, the DMZ, all right, in your own words, the DMZ is, okay, let me say it like this. In your own, when you look at the DMZ on the network, its job, its function, its job is to do what? In your own, what do you think its job is to do? In your own words. If somebody asks you about DMZ, could you tell them what it does? Could you guys tell them?
Okay, a separate network outside of a regular network that prevents and denies intrusion or unwanted or people that don't have access.
Exactly. That's it, Vince. That's exactly right. That's exactly right. Okay. So with that being said, all right. Okay. So the DMZ's function is to, like you said, Vince, is a function as to separate networks that rest outside of the secure network perimeter. Untrusted users can access the DMZ, but cannot enter the secure network. So it's like a buffer. It's going to stop you before you get into the real stuff. So DMZ is going to block you and stop you from getting to the real stuff. It's going to stop you on the outside. You're not getting in. Okay, you know, so it's going to stop you from getting into the real stuff. All right, that's what it is. Okay, all right. Here's a example of what I found that I thought might be pretty good. Where you have the internal LAN, internal firewall, DMZ LAN. You got the DMZ on the outside. You see that? You got the DMZ on the outside, and you have the external firewall. Then you have the internet. So you got the DMZ right there. Right? Before they can get to anything, they're gonna have to go through the DMZ, and the DMZ is gonna block them. They're gonna block them. If they're not required, it's gonna block them. Okay. All right. That's what a DMZ does. It's gonna block you on the outside, so you can't get into the inside. You can't get into the good stuff. All right. All right. Here's what a network address translation is: NAC, NAT. An NAT is a technique that allows private IP addresses to be used on the public internet. That's the definition. I know this is a lot, but the real, it's a lot. I think I'm going to change this slide, my next class, and just put it's a technique that allows private IP addresses to be used on the public internet. Public IP addresses, which are listed on the next page, but the main thing is it's a technique that allows private IP addresses to be used on the public internet. So on page 261 under NAT, that definition that they have is the one that I'm going to change. I'm going to change this slide to match this. So I mean, it's saying the same thing, but it's a lot of stuff. I can do a 2 bullets and that's it to get you to understand exactly what it is. All right. So on page 261, make sure you put an asterisk behind the net. The NAT and the definition that's right there, the first line, it's good. Okay, on 261 of your book, the first line is good. Okay, first line is really good. All right. Okay. All right. Okay. All right. Here's just a slide of an NAT. Okay. You have the subnets, Ethernet router, gateway, internet, home network. Okay. And you have the NAT. And like I said, NAT replaces a private IP with a public. So IP was private, now it's public. So when it becomes public, when something is private, that means, can anybody see it? Can everybody see it? But if it's private, that means you're not going to be able to get on it, are you? Because it's private, right? But when there's a public IP, what does that mean? What's the difference between public and private IPs? What's the difference?
Public basically goes through or at least to the internet. And obviously, private doesn't hit or I guess goes out to the internet. It's kind of internal, I guess, if you will.
Yeah. Yep. Exactly. Exactly. Okay. All right. So what I want you to know about the NAT, it makes a private one and turns it to a public one. Okay, lets a private one become a public one. Right. So the NAT on page 261, the definition on there under 261 where under the NAT, that's the best answer. And I think I'm gonna change my slide to that. I like that more so than I put one up there, but this is better. It's to the point. Okay. All right. Now this right here, you guys pretty much know what this is. You got the intranet. Okay. Intranet is what? What is the intranet? Intranet deals with, what does the intranet deal with?
Internal network.
Your internal network, right? Okay. Then you have the extranet. What is that? It's people from like the vendors and stuff. Okay. Like the vendors, private network that can be also accessed by authorized. Only people that are authorized can get into this. Only people that are authorized can get into this extranet. You have the internet, a private network that belongs to an organization that could only be accessed by approved internal users. Okay, where I work at the NIC, we have an intranet where only the people at the NEC can see it. Only the people at the NEC can see it. You know, like our slides and stuff like that. Then you have the extranet, where a private network that can be also, and the only way that they can get into it is if by invitation only, or if they've been, given access to it. Then you have the guest network, a separate network that anyone can access without prior authorization. So when you think about a guest network, on our network, if you log in as a guest, you're only gonna do certain things. You're only gonna do certain things on the guest network. They're not gonna you're not gonna have full access, and none of your stuff is gonna be saved because it's a guest network. All right, on the government. Okay, it's not gonna be saved at all. Permits access to general network resources like web surfing without using a secure network. That's exactly what a guest account does. All right, so you got extranet, external net, and internal and intranet. Intranet, private within the organization. Extranet is still private, but it gives the outside agencies a chance to get in as long as they're invited.
Okay.
All right. All right, now you have network segregation. Network segregation. I'll let you read it. Okay. Another way of providing security. Another means of providing security to segregate the network and its resources. Okay, it's just another way of providing. How would you segregate the network? How would you do that?
We do it at my job. We have
Okay, go ahead.
two different IP address groups.
Okay.
At Central Prison, we have the Central Prison side, and then all those IP addresses are within a subgroup, and then you have another group for the hospital side.
Okay.
So there's very limited internet access on the prison side, because again, that's where all the inmates are. But for those nurses who go to that area, they're in the private network, or excuse me, they all have static IP addresses.
Okay.
Which are different from, but the group itself different from the hospital side.
Okay. So, all right. So I'm gonna give you an example for us, and that's good. All right. So we have it set up where we segregate the network by by groups, like you said, by groups. Okay, and we do it in such a way where if you belong to the accounting group, then you're on this one. If you belong, your IP ranges from this to this. If you're on whatever, your IP ranges from this to this. Do you guys ever have to flush the scope? You ever run out of IPs where you're at in the prison? Okay, and then
especially the network printers. The network printers sometimes they lose the IP address, and there have been times where they somehow they went from static to DHCP, and then you have a lot of IP conflicts.
Okay. So for you guys in the prison, right? Are you running a print server?
Yep.
Okay, you're running a print server. So anywhere in the prison you can go and print. If you're on the computer.
If you're within that group. Again, within that IP range.
Okay, so when you guys do that right now, who manages y'all's Active Directory? Do you manage it? Do you have access to your Active Directory?
Kind of, sort of. I have, let's say, medium security, and then we have network group technicians located outside the facility who can basically add and remove.
Okay, so you guys don't have access to being able to move objects around.
I can't now.
Okay.
I had before, but not here at the prison.
Okay, so if somebody needs to move to a different OU, you can't move them.
Right.
Okay. All right.
I know it's simple, right?
Huh?
I said it's a simple task, but yeah, I can't do it.
Really?
Yeah.
So if you need to move it to a different OU, who you got to call an outside person to do it?
I got to send a ticket. If someone wants access to, for example, if you want access to H drive, you want H drive created, I have to send a ticket. If you want access to network drives, I have to send a ticket.
So
but if you want your password reset, you can do that.
You can do that. So you got shared folders and all that stuff. You got stuff that you can. So can you deal with the calendars and all that? Can you do any of that stuff?
Limited.
Limited. Okay. All right.
That's the kind of job I need. I need a job like that where I'm limited. You know, where you ain't got to do nothing. I mean, I send a ticket out. I like that. Hey, give me a job
like
limited.
I said before, it's what my friends think I do versus what I really do.
Well, on the other side, we're on the we work at the NEC, totally different. We can move people. We can do all kind of stuff. All right. I can kick you off the network with a flip of a button. I can change your PIV from a 10-digit to a 16-digit. I can man. Now, can you remote into the printers?
Oh yeah, I can do that. Certainly do that. Now, when I was at UNC Healthcare, I had all the access that you mentioned. You know.
Okay, so you can remote into the printers.
Mm-hmm.
Okay, good deal. All right. And so for you guys, IT people have different. Where it depends on where you're at is your job description. I know what people say, but wherever you're at, if they say your job is just to turn the phones on, you're the IT tech. Your job is to turn the phones on. That's all you're gonna do. Am I correct? That's all you know.
Exchange
look here. You cannot. If they tell you your job is to take the trash out, you cannot step out of. You cannot do anything outside of that because somebody else's job is to do from A to Z. From A to B is your job, but you better not go out from B to C because somebody from B to C is gonna say, "What are you doing?" But in my case on the NEC side, we do a whole lot of stuff, man. When I was over in special operations, there's a lot of stuff that we do too that a lot of people don't do. Then when I went to the NEC side, they don't do what the special operations side does because it's a different mission. The NEC does all of brag except for special operations. Okay. Because it's totally different function. So an IT guy can be exactly what it is. They just tell you, okay, this is what you're gonna do, and you better not go out of that thing. But you have people that say I can fix it, then you screw it up, and that's just a whole nother story. So network segregation. I know I kind of got on a tangent a little bit, but make sure you understand what network segregation is. Okay, make sure you definitely know what this is. All right. So let's move on. Then there are two basic methods. You got the physical and the virtual. And so with the physical, and okay, when the difference between physical and virtual is what? What's the difference between physical and virtual? What's the difference?
Tangible.
Exactly. Virtual kind of rides the backbone of something else, doesn't it? There's no really no, they own nothing. They're using something that's already there. Okay. The physical is just like, it's there. Virtual is just like I said, it's virtual. Okay. So there are two basic methods. You got the physical and the virtual. So like I said, the physical one is the most secure method, but it's also the most difficult. In this method, each segment must have its own internet connection, physical wiring, and firewall. So a physical one is tangible. It's got to have all these things for it to work. On the other hand, a virtual one it rides the backbone of the physical one. Okay, I don't know if you guys remember back in the day, they used to have these things you could put on the computer, and it made it look like there was another drive, but it really wasn't. It was a virtual drive. Y'all remember that? Y'all don't remember that. Y'all young ones don't. Okay. And well, you could it acts like it's a CD actually going in, but it really wasn't. It was a virtual. It was right in the back of the physical one. Okay. So now we talked about the physical and the virtual. Let's talk about the virtual segmentation. All right. Now this is where the VLANs come in. Everybody know what a VLAN is? You heard of a VLAN? What a VLAN does? Okay. Why you need a VLAN? Why do you need to separate this VLAN from this VLAN? You need to make sure that you understand that all the printers are going to be on a VLAN. All these computers are going to be on a separate VLAN. Okay. Some printers are set up. Some phones are set up with VoIP, and the port has to be set up for VoIP, so the computer and the phone can use the same port. Y'all got me on that, right? Everybody knows what you guys in the prison have VoIP phones. You guys use VoIP? Okay.
Yep.
So, all right. So VoIP, in order for and it has another thing you run into too. On the printer side, you ever seen it where you have a conflict with the printer and the computer, where the computer and the printer have the same IP? Has that ever happened to you before? If it doesn't, it happens a lot. What happens is they fat finger it, and they make the port in that shouldn't happen, but it happens. The printer and the computer cannot have the same IP address. You're going to have a conflict. You have to go in there and reconfigure the port to make sure that it's set up on that VLAN for the printer. It can't be the printer and the computer can't be on the same VLAN. It's got to be segmented. Okay, that happens. You just got to go in and reconfigure the port. Okay, because if you don't do it, they both have the same one, something is not going to work. And you ever notice this too? If this never happened to you, where you have two computers with the same IP address, what happens? Can anybody tell me what happens with that? If you got two computers with the same IP address, what happens when the customer tries to log on?
You can't IP conflict.
Okay.
Sounds like a collision.
Okay. So, but what happens though? You guys said it. If two people are trying to log on with the same IP address, what happens?
IP conflict. Someone not getting through.
Yeah, exactly.
I thought it would block both of them, wasn't it?
First.
No, whoever gets on first, they get on first.
Going through.
And then then the other one's gonna be like, "What's going on? I can't get on," because it's an IP conflict, just like you guys said. Everybody said the same thing. It happens that way. And for you doing the troubleshooting, the first thing you got to check is the IP. Check the IP. I was on yesterday, now I can't get on. So what you do, process elimination. You go in there and do IP config and see. And once you figure out that they both have the same IP, then of course you're gonna have to go in the port and switch it. Now, in the prison, do they give you the opportunity to go in and configure the switch? They let you guys do that? Where you can go in and no? Okay. All right.
Hey, that's why I want that job. He ain't doing no switching.
Okay. All right. Okay. Okay. This is a VLAN and IP address mask. All right. So all I wanted to show you on this is when you look at this, right now, you see how it's configured where you have the configured for VLAN 10, you have MAC, you have the B and the A, and then you have the configured for the VLAN, you have 20, you have C and D. So everything on 10 is going to be, they're going to be this together. You got AA, BB, then CC and DD is going to be on the VLAN for 20. Now those could be whatever they decide them to be, they can be that. And that's how they break up the different VLANs. That way you can have accounting on one, hospital staff on another, so it's broken down that way. All right. And I just wanted to show you this. This is just, you don't have to know this, but I just wanted to show you how it's done. And if you go in and look at a switch, you'll be able to see, you'll be able to trace it. And that's what we do. We can go in there and trace it and find out where you got no link light, something ain't working. And then you can trace it. Okay. Now for you guys that want to be network people, you're going to do this. Everybody understand? If you're going to be a networker, you're going to do this, okay? So out of the IT field, which job do you think is the easiest job in the IT field? Which job do you think is? Go ahead.
I can't say it's the easiest. I mean, they're all challenging and they're all right. I mean, but
no. Well, there's some that are easy.
Oh well, yeah, true.
You know why I said it? The reason why I said it is because remember, the IT job description is the job that the people give you.
Hmm.
You see what I mean? Your job could be just turn the computers on. That's it. I know you guys know I'm kind of.
No, I understand.
You understand what I'm saying? Whereas that could be hard for somebody, especially if somebody has a problem walking.
Mm-hmm.
And you have to go to the different classrooms and turn on the computers, all right? Or you have somebody who their IT job is to manage Active Directory, okay? Your job is to manage Active Directory, make sure the OUs and everything's corresponded, make sure you can if a user calls, you might have to reset their account or whatever. Your job, you need to make sure that you do that stuff, okay? So again, like I said, the IT position is on your job description. You're on your job description, right? Your job description says, okay, I'm going to show y'all something. Here's my, y'all can't see this, but my job description is right here. My job description says, I'm a GS12, right? Well, my job description says, it's 12 pages. My job description, right? That's my job description. 12 pages long. Now, man, oh man. So everything on here I'm supposed to be able to do, right? I'm supposed to do all 12 pages. So do I do all 12 pages? No. No, I don't do all 12 pages. But they can hold your feet to the fire and say, you read your job description? Even though you don't do this, guess what? We can make you do it because you signed the paper saying that you would do it. So 12 pages for my job description. And you know what? There's a lot of stuff. Go ahead.
Don't they do that because they have the flexibility in the office to move the IT people around the way they want to, according to the need?
Let me tell you what. You know what? You're right. You're right. You're exactly right. Because This week you might be doing the imaging. You might be in the image facility imaging computers for the rest of the month, from the whole post, the sipper and nipper. Okay, that's what you're going to do today. Do this month. Next month, like before this class started a couple months ago, I was working overtime for 6 months. I think it was 8 months. And I was working 20 hours, 10 hours on Saturday and 10 hours on Sunday, every weekend for 6 months. My job was to go in and do it. Does anybody know what a STIG is on a computer? How to STIG a computer? All right, or a desktop or whatever. But here's the thing with a STIG. What a STIG is what comes out and it says all computers must be set up this way. Okay, it's a thing that comes out. You have to go into each computer, into the directory, and you have to go into and make sure that everything, if it says that the port number needs to be 1, you have to go in and change it to 1. If it says it needs to be 2, you need to go. So again, like we said before, everybody's job is different. I don't talk about IT people because that day they might not be doing nothing. The next day they might be doing something. So the point I'm trying to make is take advantage of it while you can. All right, take advantage of it when it's slow. Don't tell nobody. Just take advantage of it because it's going to get fast. Okay, I just wanted to show you this. This is another slide with the different VLANs separated. Like we have you see where we have the HR clerk, the VLAN 10, 20, 30, 40, and they're all of these are different ones. All of these represent something different. Everybody got me? That's all I want you to see. All of these represent something different. You got the wireless access point, you got the you got the HR and DB servers, HR applicant servers. All of these represent something different. Okay. All right, everybody got that? You got the tablets where the I don't think they make these no more. Those Palm Pilots. I don't think they make them no more. But I just wanted to show you the breakdown and how it looks. Okay, the different VLANs broken down and what they represent. Okay, all right. Now let's talk about air gap. Let's talk about air gap. This is something you got to know too. Like pretty much all this you have to know. All right, and like I said, air gap is exactly what it says. It's a security measure implemented for computers. Computer systems are networked requiring airtight security without the risk of compromise. Airtight, it means it leaves no air. When I say no air, no room for anything to get in there. It's airtight. That's what it covers the gap. That's what it does. Okay, it covers the gap. You're not getting in because it's protected by the air gap. That's what it does. It's a mechanism and it does that. Okay, it does that. All right, air gap. Okay, you have the air gap. All right, this is sometimes, like I said, the air gap is sometimes the absence of any types of connection between devices in the case that secures the network on another. So it's going to make sure that it's going to be a security measure. It's going to be implemented for computers. Computer system network require airtight security without the risk of compromise. So it's going to make sure that there's no compromise. Okay, so it's a security measure. Air gap is a security measure. Make sure you understand the air gap is security measure, and it's on page 263. 263. Okay. All right. And here's just an example of an air gap. All right. This is just a model. Okay. That's just a model. I just want you to take a look. All right. You see, you have the hacker guy on the outside. You have the air gap. Ain't nothing getting in. Okay. Ain't nothing getting in. It's a security mechanism. Nothing getting in. Security mechanism. Okay. It's going to fill the gaps. That's what it does. Air gap fills the gaps. Nothing's getting in airtight. In theory. Okay. In theory, it's supposed to be airtight. All right. So let's look at NAC. NAC, network access control. Network access control is an approach to the network management and security that enforces security policies, compliance, and management of access control. Okay, so when you see this network access control, it pretty much tells you, the name pretty much tells you what it does, doesn't it? Doesn't the name pretty much tell you what it does? All right, this is one of these terms where the name tells you what it does. The name pretty much tells you what it does, okay? The name tells you pretty much what it does. All right, so I'm not going to beat this up, but the network access control tells you, the name pretty much says what it's going to do, all right, for the network, okay? And you can find this on 265, all right? Tell me, this one, no, I don't have to put that up there. I was supposed to take that out anyways. All right, now you have the DLP, the data loss prevention. I'll let you read this. This is important. Okay, everybody see that? Refers to the identification and monitoring of sensitive data to ensure that it only accessed by authorized users and that are safeguarded against data leaks. So remember, the name alone, data loss prevention, tells you right there. It tells you right there that it's gonna protect, it's gonna stop the data loss. That's what its job is, okay? DLP is gonna stop the data loss, okay? It's gonna monitor what's going on. It's gonna make sure that it safeguards against data leaks, okay? It's gonna make sure that it safeguards and protects the data. It's gonna make sure that it does that. It's gonna make sure there's no links where stuff can get out, okay? So remember, it's kind of like a protector. All right, so it's going to protect, okay? All right. Here's what a DLP, it's just another example. What it is you see the data lock, and it's going to make sure that everything is locked and secured, okay? And here's the different, here's how data loss prevention works, okay? This is just another slide. Now, it's just another slide just to bring it home a little bit. Okay, bring it home a little bit, bring it home a little bit. All right, data loss prevention. It's going to make sure, that the system of security tool that is used to recognize and identify data that is critical to the organization, ensure that it protects it. If it is important to the organization, then data loss is going to protect it. Okay, all right, good deal. All right, this is chapter review. It's everything we learned in chapter 6. All right, chapter 6. All right, everything we learned in chapter 6. Okay. Now, I want to take chapter 7 is very short. All right, it's really short. Well, it's not as long as chapter 6. So it's I'm gonna take it like a 10-minute break, and then we'll get into chapter 7, and then we'll be out of here. Everybody good with that? I know this is a lot of material. I know I'm trying to get through it so we can get done with this. So, because I really want to start putting this, the slides up so I can show you some of these simulation questions and see how good you guys do on them, because you're going to see them again. Okay, so it's what time y'all got? 8:55. So let's come back at 10 after. How about that? Is that cool? And then we'll pick back up. Okay. So at 10 after we'll come back and get this knocked out. Okay. Thank y'all. So how long you been working in the prison system? A while?
Next month will be 3 years.
3 years? How you like
next
it?
month.
How you like it?
It's not too bad. I've had more usage of my skills other places, but I think it's just design how it is.
Right. What is your end state? What is the goal you're trying to reach as far as in IT? What do you want to be?
Honestly, I want to go as far as like project management. I just want to be director and stuff like that, but that has a lot of responsibilities and a lot more schooling. And I don't think I'm really interested in all of that aspect. But I do like the aspect of project management or networking.
Why don't you just go get your PMP then?
I'm working there.
Okay, because
I've had things where I've had project management type, organizing different departments when it comes to refreshers and stuff like that. I'm part of that. With UNC, has something called the Go Live with Epic, basically their electronic medical record. I was a part of that. Just saying, different departments, hey, we're going to implement this new idea. Here's the training and all that good sorts. So I had project management in that aspect, and I kind of like that, But this field is for those who don't know, this field is so broad. It's like there's so many things you can do, and then the umbrella is ridiculously huge.
It's huge. It is huge. But see,
because I did everything from,
No, go ahead.
No, I'm saying I've done everything from working in computer repair stores to working with Apple to working in the bank, working in a hospital, and now with the state. So I dabbled in that. I also did some programming. So I dabbled and dabbled almost in every aspect that you can think of.
That's good stuff. Actually, the more stuff you know, the better you are, because it makes you more well-rounded, and then it doesn't limit your possibilities. Working for the government. Okay, so dealing with Windows, we don't, and on the government side, we don't deal with Azure as much as my friend who works for corporate America. They deal with Azure, which Azure is what's on the Windows 10 certification test, and it's mostly done on the corporate side. No, not military. So it's like a learning curve. Even though I have the certification, we don't really do the Azure on this side. So when you go take a certification, even if you don't know about a particular thing, you have to know it for that exam. You see, so it just prepares you. The exam is really going to prepare you to see how you would do or how you feel about this particular field, and especially program. You're doing some program manager stuff now. So the key to that is, if that's something that you want to look into, then of course the next step is to do the PMP and get that. So that way you can be a certified, even though you got the experience, now you got the certifications. Remember I told you, it's about the certifications, man. You know what I'm saying? You can still do the job, but but to get the money, you need them certifications. You get what I'm saying? That's the thing that they're pushing that. You could be very, very smart. I'm sure a lot of you guys are, but it's all about the certifications, man. So that's why it's a thing. Now you just got to figure out where you want to go, what part of IT you want to go into. Then you can get your certifications for that. But PMP would be a good move, man, for you if you definitely want to do project manager, which I see you're doing some of it now. But to get the top tier money, you need that PMP. Okay, that just says this guy went the extra mile. That's just like with the Security Plus exam, Net Plus, A Plus. These things, or you might have worked in a computer store for 20 years. You know a whole lot, but you don't have the certification. You get me? So you can't get that money that somebody who has the certification can. You get what I'm saying? Because you got the cert now. You can kind of like be, look, I got the cert. This is what's required. I have it. Opposed to somebody who doesn't have it. So that's something just to look into if you really want to go to that side. You got time. Okay. So just again, like I keep iterating, it's about the certs. I was just like you guys. I got the military. I had everything, man. I thought I did. Oh, you got a master's, you got this, you got all of this, you did this in the military, you taught schools, you did this, and man, do you got the cert? Well, I got all of this. Yep, I see you got all of this, and I did this, but you got the cert. That's all they kept saying. It's like they didn't hear nothing else I was saying until I said, and then when I got the cert, then they wanted to talk to me then. I'm the same person, right? I got the same credentials. The only thing that's changed is I got the cert now. And that's what happened to me. I can only talk about myself, but that's what happened to me. So I tell you guys, you go to school, get your education, but key on these certs, okay? Because they are really on it about these certifications, man. It's just, you could be smarter than anybody else, but without that certification, you can't get in the door. They won't even let you in. You know that, and who's the one that works? Somebody works at the bank, and the person that works at the bank said it didn't require Security Plus, but now it does, and because it's a world-renowned cert, they figure if you get this cert, you know what you're talking about. You guys know that ain't always the case, all right? But that's what they look for. Okay, so this is chapter 7. This we're going to talk about chapter 7. Chapter 7 is not long at all. Okay, this is what we're going to look at. And I told you the 6, 7, and 8, 5, 6, 7, and 8 are dealing with network stuff. Okay, so this is what we're going to talk about, which is on the outline on page 281, and this is what we're going to talk about. All right, let's move on. Okay, I put this back up again because, again, like I said, some of this stuff is the same stuff. Now, the only difference between this one is you see the OS model and you see the TCP/IP model. Now you see where it has the application layer, presentation layer, and session layer is underneath the application layer. Then you see the transport layer, internet layer, and then you see the network assets layer, and you see how it's broken down. I just wanted to show you guys that, and that it's the same stuff, but now it's broken down a little bit differently. Okay, and instead of all, it's broken down into 7. One side OS model is 7 steps. The TCP/IP is 4 steps, but it's actually 7, but it's actually 4. They just got it broken down a different way. And like I said, the application level has the 3 application level, presentation layer, and session layer. Then you got a transport layer, internet layer, and then of course the dynamic link layer and the physical layer, the network access layer. And that's just wanted to show you the difference between them when you look at when somebody says the OSI model and the TCP IP model. And this is the difference between them. This is what they look for. This is what they look like. One has 7, one has 4. But when you really look at it, it's the same thing. It's just set up differently. Okay. And we already talked about this. Okay. This is just, all right. Like I said, this is in the part of the slides again. All right. So we talked about here's the difference between the OSI, TCP, IP, model. This is just, all right, so what I want you to key in on this is, like I said before, the OSI model has 7 layers. The TCP transport model has 4 layers. Everybody see that? That's what I want you to key on. 7, one has 7, one has 4, and then with the OSI model, you guys know whatever that thing y'all came up with, Sally eats tomatoes or whatever it was that he did, whatever he did, you know. Okay, so now I want you to understand TCP/IP has 4 layers and the OSI model has 7 layers. Okay, all right, the difference, one has 7, one has 4. I have it in bold, so you know when you see if you ask that question, you know what the difference is. All right. Okay, now you have the SNMP. Now, I'll let you read it. Now, what I want you to know about this is just the first bullet. It's a set of protocols for networking management and monitoring. That's what I want you to know. It's a set of protocols for network management and monitoring. That's what I want you to know. All this other stuff is just other, you know, supporting documents, but the main thing is a set of protocols for network managing and monitoring. That's what I want you to key on. The other stuff is supporting documents, but this is SNMP is what you need to know. That first block, that first bullet, okay? That's what I want you to know. All right? Okay, that's what I want you to know. Make sure you know that, all right? Make sure you know that, all right? Okay. And that's on page 285. All right, so here's a diagram of the SNMP network management application. This is how it flows. You got the telnet, serial port, SHA, access to CLI. Okay, this is just showing you the process, how it works. Okay, but remember what I told you. What you want to know about the SMTP is what it does is a set. Okay, that's what you want to know about it. You remember, it's a popular protocol used to manage network equipment, and it's supported by most network equipment manufacturers. It allows network administrators to remotely monitor, manage, and configure devices on the network. SNMP function by exchanging management information between network devices. Okay, that's just a different definition, but it's on page 285. This diagram is just showing you how it works, how it manages the different devices. Okay, all right. Now on this SMTP protocol, what you want to know is 3. SNMP version 3. What is the latest model of SNMP? The first and second model, the first and second series, but the one you want to know is the 3. This version is improved security and privacy. It was introduced by RFC 3410, which is an organization. So remember, you want to know you want to know what SNMP is for the network, but then you want to know which version is the one. And the version that you're looking for is 3. The version that you're looking for is 3. They might have 1, 2, 3, 4, 8, 10, 15, but the one you're looking for is version 3. It's the most improved version. That's the version that you're looking for. Okay, that is the version that you're looking for. All right, and then you see right here, you got SMTP security comes in 2 primary forms. You got authentication and privacy. Everybody understands what authentication is. If you don't authenticate, you get nothing. You don't authenticate, you get nothing. If they can't authenticate you, you got nothing. They're not going to give you nothing. You're not going to get anything because they can't authenticate you. All right? They can't authenticate you. Then you have privacy, which encrypts the payload of SNMP message to ensure that it's only read, that it cannot be read by unauthorized users. So what it's doing is telling you that once you authenticate, the privacy lets you know unauthorized user are not going to be able to use it. This is SNMP3. This is what 3 does. And it comes in 2 forms, authentication and privacy, which you know that what authentication does, and privacy is exactly what it says. You cannot see this. It's not going to let you see this if you're not authorized. Okay, so remember, you want to key on the SNMP version 3. When they ask you, that's what you want to key in on. And then, of course, what the simple network management protocol is defined and what it does. Okay, and what it does, manage network equipment over the network. Okay. All right. Everybody knows what DNS is, domain naming system. Everybody knows what that is, right? Do I need to go over that again? All right. Domain naming system, what it does, how it works. And like I said, it is when you put your IP in there, sometimes you get the DNS is not resolved. That means they can't find the name that you put in there in the browser. That's what happens. But you can go in and check it. There's a way you can go in and find out if the name has changed or if something's going on with it. There's a code that you can do, and it will let you know. But remember, domain naming system is domain name to IP address to make it possible to assign domain names to groups of the internet resources and users regardless of the physical location. Domain naming system. Domain naming system. Make sure you know what domain naming system is, what it does, okay, and how it works. All right, what it does and how it works. And now, let's look at, I'm going to show y'all something. All right. This is how you put it together. Okay? This is how you put the domain naming hierarchy. This is what happens. This is how you come up with the result. First, you got the root. You see the root, you got the root. You got the you got the root. Okay? You got the root up there. Then you have whether it's a COM, EDU, ORG, or other. Okay? Or other. That's the top level domain, TLD, top level. Then you have the second level domain, which is the name, Computer Hopes, MIT, Craigslist. Okay, then you have, that's the second level of domain. Then you have the subdomain, which is support Salt Lake City. Then the final result is what you see at the bottom. You have support computerhope.com commercial, then you have MIT educational, and then you have Salt Lake City Craigslist organizational nonprofit. Y'all see how this is how it comes together. This is how they come up with these names. Okay, if you just had Computer Hope in there without no .com, edu, or org or other, then it would probably be looking for a definition. Okay, but you have to have all these pieces to make this result come out to be the result. Okay, domain naming hierarchy, this is how it works. This is the result. And this is how it works. Okay, this is exactly how it works. All right, but really with this, this is a good slide. But actually, just know what DNS is. Know what DNS is, and what DNS is and what it does for you. Okay, what DNS is and what it does for you. All right. Then you have, this is the same thing, but I just another slide. All right, and remember, you got the www.dns.com, then the changes to the 63.155 whatever to the IP address. It searches the web, then it finds the IP address. I mean the computer where the what the name of it is, and then it takes you to that page. Okay, that's all it is. The same thing that I just showed you. It's just a different way of doing it. Okay, same way I showed you, a different way of doing it, but it comes out with the same result. All right. Okay. All right. Good deal. All right. And then here's another one. Here's the domain naming structure, which I just told you, a fully qualified domain name, FQDN. You're going to see it again, FQDN, fully qualified domain name. That means it's fully qualified. That means it is a domain. And this is, like I told you, what I showed you earlier, this is what it comes up to be, and it makes it a fully qualified domain name. All right, fully qualified domain name. That is how you come up with that. Okay, that's what makes it a fully qualified domain name. If it didn't have .edu, if it just had hills.ccsf, it would not be fully qualified name. It has to have edu.com or something to make it a fully qualified name. All right, that's how it comes up. All right, then you have this one where it says what is .com. I have the IP address in my cache. What is .com map 206.19.94. So as you can tell, it's looking. How do I get to whatis.com? And it says, okay, this is what you have to do. Thanks, I'll send it to the client and cache it for the future. The IP address is not in my cache. I'll ask another DNS. So what it's doing is going to the different DNSs, saying, hey, what is this? What is this? Then when it finds the right one, then it's going to let you know that this is what this is. Okay. So again, the DNS exactly, it resolves if it doesn't resolve the name, you get nothing. All right, you won't get anything. That means it's bad. Okay, that means it's bad. All right. Okay, then you have this right here. You got to know what the DNSSEC is. That's what it is. Domain name service security extension. All right. Now, this is like a protector. Okay. Make sure you know what the DNSSEC is. Make sure you know what it is. You're going to see it again. All right. Make sure you know it. You're going to see it again. Okay. DNSSEC. All right. Which is fully supported by bin 9. All right. So that's just something that you need to know. Bin 9. I don't know all the history behind it, but bin 9 is definitely on the test. But actually, it's not on the test. It just relates to this. Okay. But the DNSSEC, you need to know what that is. All right. Now here's an example of what without the DNSC, this is what happens. On the left side, without the DNSSEC, this is what happens. Without it, it can cause damage. It can result in damage to the majorbait.com reputation. Okay, but with it, this is what happens. It's going to question. It's going to question it. Hold on. So remember the DNSSEC without it, it could result in damage to the major.com reputation. With it, it can protect it. Okay. Well, the DNSSEC adds additional resource records. These records define the data types being used and message header information, which can be used to verify that the requested data has not been altered or through the transmission. So again, without the DNSSEC, what will happen is it's not going to verify. It can't verify if this hasn't been tampered with. But with it, it can verify that it'll verify that it has been, if it's been tampered with. The other one without it, it can't. With the one with it, it will. Okay, DNSSEC. All right, this is just another one. Same thing, I just wanted to show you what'll happen, but it's the same, pretty much the same thing. All right, now you got the file transfer protocol. Y'all know what support for FTP? What support for FTP? If y'all remember. Y'all remember?
Is it 21?
Anybody else? 21? FTP?
20.
Huh? 20? Anybody else? Okay, anybody say 22? 20, 22, or 21? Any one of those. Anyone, yeah, correct. It's correct. Okay. And this is what a file transfer protocol does. It can be one of those, okay? It may authenticate with the username and password. All right, so file transfer protocol deals with what? Exchanging of files with host computers. Okay, that's all it does. File transfer protocol deals with exchange with host computer. Then you have, these are various types. You don't really need to know all that. That's just another slide. Okay, and then you have the internet firewall server. This is what file transfer protocol looks like. Okay, you got the client, internet, firewall, and server, and it just keeps going. So then, if you got the FTP, how do you secure FTP? Well, so if you got file transfer protocol, you want to also be able to secure it. So how do you secure it? What would change on this? How would you secure it? It would do this. You just add an S to it. Now you're going to add secure socket layer and TLS. And take note, FTPS is also known as FTP secure. Okay, take note of that. All right, please take note of that. Okay. Okay, please take note of that. All right. You got FTP and FTPS. All right. Okay, now you have secure file protocol, transfer protocol. All right, it's a secure version of file transfer protocol, FTP, which facilitates data access and data transfer over a secure shell data stream. It is part of the SSH protocol. This term is also known as SSH file transfer protocol. Okay. All right. Okay. All right. Now, this right here is in your book. You see all this stuff that's on here, all this application and technology recommended. This is just to let you know whatever's on the left, this is what they recommend, the kind of secure stuff you need to use. All right. You know what NTP, network time protocol, do you guys know what that does? Does anybody know what NTP does for you? Well, what it does is about the time. So sometimes if the time is off, you're not going to be able to sync. So the NTP is very important. If the time is off when you try to do certain things, and it can cause you not to sync because the time is not accurate. It has to be the same time for it to sync. And if you haven't ran into this problem before, keep doing IT, you will. And you'll be like, I done did everything. And you find out that it's the time. That's why it's not working. Okay. Then you have the email, which we talked about the email, the SMIME. You got the web browser, which you know, HTTPS for secure, file transfer, and then remote access, VPN, of course. Then you have DNS, remember I told you about the DNS? The DNS extension is DNSSEC. Now, the routing and switching network address and subscription services, IP security, IPsec. IPsec, IP security. All right. So these things that we talked about, we went over already as far as the voice, video, time synchronization. Like I told you, NTP, if you don't have that correct on certain things, it's not going to work. You're going to be done troubleshoot your heart out, and you're going to find out that it was the time that was messed up. That's why you can't sync it. Okay. If you haven't dealt with this, keep doing IT, you will. Then you got file transfer protocol, which deals with files. All right. Then you have the file transfer protocol, or SFTP, secure file transfer protocol, remote access, which is VPN, domain names result resolution, and the extension that DNSSEC, of course, routing, switching network, and subscription services. All right. Now this is the placement of security device technology, which we SSL, TLS, y'all know TLS is taking over for SSL. You got taps and port mirroring, sensor collectors, filters, aggregation switch, and DDO mitigator. All right, so let's go into these. All right, this is what SSL, which I told you already about SSL. Everything you need to know about SSL. SSL is replacing TLS. Okay, SSL is replacing TLS. That's all. That's what you need to know. SSL is replacing TLS, and what SSL means is secure socket layer, and you know TLS, transport layer security. SSL is being replaced by TLS. That's what you have to remember. Okay. Now we have the taps and port mirroring. Now you got the network taps. Is it taps transmits both and sends and receives data streams simultaneously on a separate dedicated channel. Ensure all data arrives at the monitoring device in real time. So taps make sure all data happens in real time. Then you got port mirroring, is the method of copying and sending network packets transmitting as input from a port to another port of a monitoring computer switch. It is a network monitoring technique implemented on a network switch and similar devices. So port mirroring is so you can kind of think of that as when you mirror a different port. Okay, that's the way I learned it. Then you have the port mirroring, is also known as the switch port analyzer. Now you see the span and the wrap, the roving analyst port. Now the port analyzer you might see, but the real thing is the taps and the port mirroring. Now understand what taps does and what port mirroring does. Okay, now you got the sensors, collectors, and filters, which is the SIEM. What I told you, we talked about this already. SIEM, which is, it does the process of monitoring real-time environment. Okay, real-time environment. Okay, so then you have, after that, you have like I said, the SIEM. We went over this. Make sure you know what the SIEM is, what it does, which we talked about it earlier. So that's why I'm not standing on it long, because we talked about it earlier. All right. Then you have the aggregator switch. So you need to know what layer it's on. So, and what layer is the aggregation switch on? And you can see layer 1 is the physical connection between devices, and layer 2 aggregation switch is just a switch that provides connectivity for several other layer 2 switches. So it's a layer 2, and it provides help, a connectivity for several others on layer 2. All right. So remember, aggregation switch is exactly what it says. It's layer 2, but it also provides connectivity for several other layers of things on layer 2. Okay. Then you have the correlation engine. All right. Is a software application that programmatically understands relationships. All right. So when you think of correlation, just understand that when you correlate something, that means it does what? In your own terms, when you correlate something, what does that mean? Okay, that's when you correlate something, that's pretty much what it means. Okay, that's pretty much what it means. All right, I have this slide up here, right? All right, so this is pretty intense slide, but it's just showing you the different things that go on. All right, and actually, this is not really for this class, not this one. All right, let's go to DDoS mitigator. All right, so you have DDoS, which we talked about DDoS. DDoS is what? What is DDoS? What does DDoS do? Well, it's a denial service, and when it denies a service, how does it work? How does it do that? It uses more than one computer, and it takes those computers and it makes them into slaves, and then makes it into zombies, and then it attacks where it kind of like overruns them, and it makes it where you can't get on the computer. This one is done with multiple computers. DDoS is done with one computer. Okay. Now, the mitigator is a set of techniques or tools for resisting or mitigating the impact. So its job is to try to resist the attack and try to mitigate the problem. So it on the networks. Okay, so that's what a mitigator does. All right. Then you have the log file. Everybody has seen what a log file is. All right, it's exactly what it says. It's a file that keeps registry events on the computer. And anybody can get that. You just go to the computer, or even on your computer at home, you get the log files. Okay. Then you have the security logs that contains records of logins. So anything security is they're gonna see if anybody violated the policy or to get onto the computer, right? So you got the log files where they keep the registry processes. Then you got the security log that contains records of people who logged in. Remember, the difference between the log file is it's event messages and communications between various connection software, and security log finds out about who logged on, when they logged on, and stuff like that. Okay, so log file, security log, no difference between the two. All right, no difference between the log files. All right. All right. Okay, we're not going to talk about the firewall. You already know what the firewall is. You already know what HIDS is, host intrusion detection system. We talked about that. I'm not going to beat that up because we already know about that. All right, just like you all know about the firewall. Like I said, some of this stuff is redundant because it was in the last class. All right, so then you have the web servers. Everybody knows what a web server is, all right, and what it provides. DHCP, all right, DHCP is different than static. When you get on a computer, it's most of the time it's DHCP, unless it's specifically for that computer. But for the most part, it's going to be DHCP. All right, it won't be static. Static is on. DHCP is random. Okay. Then you have the VPN concentrators. All right, so you got the VPN. Everybody knows what the VPN is. So the VPN concentrators are a type of networking device that provides security creation of VPN connectors and deliver. So it's kind of like making sure that it's secure, making sure that the messages are going delivered where they need to be delivered. Okay, through the various VPN nodes. Okay, so it's going to make sure that it's carried out to different nodes. Everybody knows what a node is. It's different points where it's different points where it needs to hit. We talked about the proxies. Everybody knows the proxies is the intermediate between the client. Then you have the proxy, and then you have where it's going. All right. We talked about the main naming system, which we talked about that already. DNS. Make sure you know what it is, which we talked about that already. All right. Then you have the email servers. Everybody knows what the email server does. All right. It holds your emails on the server. You can download them. Okay, but they're still on the server. All right. On a regular computer at work, you can archive your emails on your desktop and make PSD files, but you can still pull them down from the server. All right. You got routers and switches. Everybody knows the difference between a router and a switch. All right. Which layers are they on? What's the definition of the router and what's the definition of a switch? All right. These are networking devices. All right. DEP, this right here, DEP. You will see this on your computer. If you're on the computer, this little box comes up and says the DEP comes up. What happens is there is a flaw in the coding, and it'll come up and say DEP. It'll come real quick, and it won't let you do it. Okay. All right. The bottom line is it protects against buffer overflow. Everybody knows what buffer overflow is. That's where they send too much stuff to the buffer and it overflows the system. Okay. So DEP is it's gonna protect against exploits, but at the same time, it's application from executing code that is not good. Okay. Then you have file integrity checking, which all this is going to check the files. That's all it's going to do. All right. That's what it's going to do. It's going to periodically validate the files and let you know against a known stored value, detect changes or modifications. So it's going to check the validity of that file and make sure nothing has changed on it. Okay. That's all a file checker does. Remember, it's going to check to make sure, and it's going to validate existing files. All right, and then you have, okay, application whitelisting is when the whatever the application is, they whitelisted it. So what that means is it's good to go. When something is whitelisted, that means it's good to go. When it's blacklisted, that it means it's not good to go. Application whitelisted means that the application has been proven by the authorities or whoever to say that this stuff is good to go, so you don't have to worry about it. Then you have the removable media control, which you want to make sure when you use removable media, especially thumb drives, well, you know, we can't use them in the government anyways, that people can transfer stuff with those drives to other people without them even knowing it. Then you got the APT, which is advanced persistence threat, which, you know, when something is advanced, when something is a persistent threat, that means it hangs around, right? That's what it means. It means it hangs around, it stays around, it hangs around. Okay. Application whitelisting means it's been approved. We got remote removable media control, and you got advanced malware management. All right. Virtualization is, I'll let you read it. It's pretty, I'll let you read it. Okay. Okay, that's what it is. Right. There's know the top block. It refers to creation of a virtual resource such as servers, desktop, operating system, files, storage, and network. All right. So here's what a virtual machine is. Virtual machine monitor. I'm sorry, virtual machine monitor. All it's going to do is enable hypervisors. Okay. So with this, know that all it's going to do is enable to be able to use the hypervisors. Now you got two of them. You need to know these two. What you have, there are two types, which the first one is you got the hypervisor that runs directly on the system. That's number one. Then you got number two that runs on a host operating system. Okay. One runs directly on the system hardware. The other one runs on the host operating system. You need to know these two. You're going to see them again. 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 Okay. Hypervisor 1 and 2. One runs directly on the system hardware. The other one runs on the operating system. 2 runs on the operating system. 1 runs on the system hardware. Okay. Then you have the VDI, virtual desktop infrastructure, which is exactly what it says. Virtualization technique enable access to a virtualized desktop, which is hosted on a remote service over the internet. All right. VDI is also known as virtual desktop. That's all it is, the virtual desktop interface. Okay. Then you have VDE. VDE is an internet compliant virtual network that can be sprawled over a set of physical computers. All right. So virtual distributed Ethernet. Okay. So again, you know what a virtual network is. It's not. It doesn't have anything. It has to be used with something else. So then that comes with, when you have that, this is what can happen. This virtualization sprawl. That means when you have too many virtual machines, you can't control them. They get out of control. Now you can no longer manage them. So the virtualization sprawl is what that is. That means when too many virtual machines you have and you forgot how many you have, you can't manage them, so they become out of control. Okay. Then you see you got the virtual machine escape is an exploit in which attackers run code on a VM machine. What that means is they find a way to get in, they find it, and then they attack it with code that allows an operating system running within it to break, and indirectly interacts directly with the hypervisor. You don't want that to happen. Okay. You don't want that to never happen. All right. So the sprawl is when too many virtual machines are created and the administrator can't control it. Then you have the escape, where the bad person tries to control the hypervisor. You don't want that to happen. Okay. Then you have the virtual machine, which, this is way to protect it with patches. Okay. With patches. All right. If there is an exploit, you want to use the patches to fix it. Then you have, now this cloud computing. All right. Cloud computing. All right. These cloud computing. This is stuff that you got to know. Okay. This is stuff that you must know. Everybody got me? You must know this. All of this stuff you must know. Okay. You must know. All right. You got the IaaS and you got the infrastructure as a service, platform as a service, software as a service. You're going to definitely have to know these. These are going to be on there. They're going to be on there. You're going to have to know these. Okay. But we're going to hit all of these. All right. We're going to hit every one of these. Okay. Then you have cloud computing characteristics. On them, these right here. These right here. All of these you need to know them. On demand can make changes such as increasing or decreasing. Then you got the universal client, virtually any network device. Then you got the invisible resources, the physical and virtual computers resources are pooled together to serve multiple. You got the intermediate elasticity, which can increase and decrease. Then you have the metered services, where they are controlled and they're downloaded at a certain time, and you can control them on how you're going to do it. Like, for example, you want to go this fast or this slow, you can control it, and you can control how much of it you want to go and how much of it you don't want it to go. Okay. Okay, so now these like I said, on demand, self-service, universal client support, invisible resource pooling, all these things you need to know. Okay. All right. All these things you got to know. Okay. All right. All right. Let's move on. We're gonna get done with this. Okay. We'll get done with this. I know it's late. We're gonna get done. All right. So you got cloud computing type clouds. You got the public cloud. You got the public cloud, refers to a computing service model used for provisioning, storage, and conceptual services. All right. So computer public cloud, I got an example. It's access to IC resources on a pay-as-you-go model. So public cloud facilitates pay-as-you-go. Now, that's the public cloud. Then you have the community cloud. The community cloud is a cloud that service model that provides a cloud computing solution to limited numbers. So it's also designed for businesses and organizations. So you have the community cloud that is designed for businesses and organizations. Then you have the other one that that we just talked about. Now you have a private cloud. Exactly what it says. A private cloud are often used interchangeably. Technically speaking, a VPC is a private cloud using a third-party cloud provider. Now, a private cloud is exactly what it says. Now, these different clouds, you have to know these different clouds are going to be on there, and we're going to go over them again on on Thursday. Okay. All right. So then you have the hybrid cloud. Oh, I'm sorry. You have the hybrid cloud, which is a mixture between the two. Hybrid cloud is a mixture. It's a service integrated in-house IT infrastructure with other product service to meet business-specific unique needs. Okay, so, and also, like I said, it's a cloud computing service that models that provide cloud computing solutions by combining different clouds. Anything hybrid means there's more than one combined together to make two. It's a mixture of a lot of things to satisfy a customer. Okay. Then you have cloud storage. Everybody knows what cloud storage is. That is where your stuff is stored in the cloud. There's no such thing as a cloud, which they say clouds are actually stored on a server farm. That's what a cloud is. It's a server farm. So it's stored on something physical. All right. So don't get it twisted. Cloud computing is exactly what it is. It's stored on servers. All right. All right. Utility storage. That's what it is. All right. We talked about this. The software as a service, platform as a service, infrastructure as a service, security as a service. You have to know these. All right. I'm gonna hit them real quick. Okay. So you got software as a service. It's a model for the distribution of software. So when you see software as a service, anytime you see a question with this, it's going to say something about software. All right. This is how I'm going to show you the quick answer that you can get it real quick. It's dealing with software. Then you have the platform as a service. Platform as a service is just like it says. It's a concept that describes computing platforms. Software as a service deals with software. Platform as a service deals with platforms. Then you have infrastructure. So infrastructure is going to deal with infrastructure, also known as HAAS. Okay, so it's going to deal with infrastructure. Platform as a service, software as a service, infrastructure as a service. Now you have security as a service. Well, this one is not mainly mostly used, but this is something that you need to know. But the main ones are the platform, software, infrastructure. Okay, then you have, which this is just another application, what I wanted to tell you about cloud services, IaaS, PaaS, and SS. This is just what I was telling you about. All right. Then you have CASB, cloud service, cloud access service broker. A broker is somebody who handles everything. All right. He handles all the cloud assets. He is a broker, just like a banker, just like a broker in the banking system or the housing system. A broker is somebody who brokers the deal. All right, just look at here. This is what a CASB does. He's the one who handles all of that. He directs the cloud. He does all of that. Okay. All right. He's the man or the woman. They handle everything. Okay. Then you have the SDN, which is the self-defined network. All right. So it encompasses multiple kinds of network technologies designed to make the network more flexible. So the SDN makes the network more flexible. All right. So again, this is stuff that you have to practice. And like I said, we're going to go over it again on Thursday. All right, just to make sure that everybody's good. I know it's late. All right. So, well, you don't need to know that. Okay, here's the benefits of the SDN: inexpensive, centralized, dynamic, optimized, filter, redirect, load balancing. Okay. All right. And that's it for chapter 7. I know it was kind of fast, but again, I'm going to go over some of this stuff on Thursday again, just to reiterate some of the things to make sure that you understood what I was talking about, because I know it's moving pretty fast, but I definitely, like I told you, I'm going to make sure you know what you need to know, okay? And then we'll apply it, because I want to start getting into some of the testing stuff, okay? So again, I know it's late, and I appreciate your patience. I know some of you got to go to work like I do, but again, I appreciate your patience with this class. There's a lot of material. So again, I know that there's probably not no questions, I know, because it's late. So on Thursday, on Thursday, whatever, I'll go back over, hit it real quick again to make sure, because I know it's late, and I'll highlight the topics again of stuff that you need to know. Okay, everybody good with that? Everybody good? I know it's, like I said, I know it's a lot, and I know it's late in the evening, and I appreciate y'all that stayed on, and your reward will be you passing this exam. Okay, like I said, it's a lot of material, and I want you guys to continue doing assignments. Vince, I applaud you, man, because you're on it. Okay, some of the rest of you guys are on it too. I think I graded. Who got an email from me today? Anybody? Did you get one? Nobody else got one from me? Check your email. If you submitted some work, I sent you an email to let you know, hey, I checked it. Okay. And if you look on the grade book, you should be able to see that I graded the papers. Okay. So again, you don't have to write a whole book. Just put a couple sentences that you understand and move on. All right. All right. So that will be, any questions from anybody? Like I said, I know it's late. I appreciate you guys staying on. We will pick this back up on Thursday, and I will highlight again the things that are important. Okay. So until Thursday, we'll meet again. All right. Okay. Thank you guys. All right. Thank you guys. Thanks again.
Thank you.
All right. Stephanie, you still there, Stephanie? Okay.
Yeah.
So did you see something that I sent you? You submitted something. All right. Let me know if you get on Thursday.
I saw that I submitted 1 and 2. I saw that you graded 1, but I didn't check after for 2. But I didn't get any email.
Okay. You didn't get nothing to say? Because when I do it, it says, okay, send an email to the student and let them know that you checked it. No, you didn't get nothing on 1 either? Okay. Okay. If you don't get nothing on when we talk on Thursday, let me know. Because you're supposed to get something. Okay. So again, I appreciate you staying, Steph. How you feeling?
My brain hurts.
It's a lot, ain't it?
It's a lot. I already knew with the classes. I already knew I was going to try for Net Plus first. Because I'm not taking Security Plus test first.
It's a lot, isn't it?
Yeah, it is. And I'm not in IT, so for me to go to a whole new. The thing is, it's a lot, but it's not as technical as A Plus and Net Plus. So it's a little bit easier. It's just a lot more to remember.
A lot more, because what Security Plus does, it entails A Plus and Net Plus, and now you got to know security behind it.
Right.
Yeah. So again, like I said, I appreciate you hanging in there. Because like I said, it's a lot. It's a lot. And then as you go up, now what do you do now? What were you
I'm
doing?
an asset
What was your
protection manager.
who?
Asset protection manager.
What does that do?
So you know what loss prevention is for retail?
Oh, so you be out there hawking people down? That's what you be doing?
Mhm.
Really?
Mhm.
You be
And
chasing
I
them down, Stephanie?
investigate the internals, the employees who are stealing.
You actually do that?
Mhm.
Go ahead, Steph. All right. You got a gun? You got a
Yeah,
gun?
but it doesn't pay as well as IT, you know. So yeah.
I understand. I understand. Listen, if you keep doing what you're doing, you'll be fine. Okay. And then, like I said, I'm gonna go over all the stuff and make sure that you really understand this stuff. And then when you get ready to take the Security Plus exam, you're gonna have everything you need. What I tell people is, even though you get out of this class, you still gotta study because it changes so quickly. It changes, and I've been teaching this for about 5 years now. So it changes. Now I teach other classes too, but it changes. And I have to kind of understand, try not to get too technical because I try to stay on topic because I can kind of go off to the other stuff. But again, like I said, just if you have any questions, I just want to make sure that you're getting the emails that I'm sending out. So on Thursday, just let me know if you get them, okay?
Okay.
All right. Okay. All right, Steph. Take care.
Have a good night.
All right, you too. All right.